Hey everyone, and welcome to the second day of our career track at Worldwide Software Architecture Summit. My name is Paul, and I'm going to be your host for the next 3 to 4 hours. And let me introduce our first speaker for today's blocks, and it's going to be Ronald. He is a lead software engineer at PT PyFast Technology Nora Santra. Hey, let me pull you up. Hey, Andrey, how are you doing?
Paul. I'm doing great. How are you?
Doing great. So, just a quick introduction. What you're going to be talking about? What's going to be the topic of your presentation?
Yeah, it's pretty much about migrating from monolith to microservices. And yeah, we may share about what you need to be prepared of and what might you need to overcome when you are dealing with the migration process. And
Cool.
yeah, what's another the trade-offs whenever you already decided to move to the microservices, and then there is
Hmm.
always a trade-offs to be overcome at that point, and then we want to discuss about it. So that's we are
Yeah,
going to
definitely.
discuss. Yeah, pretty
That's
much
that's
today.
that's going to be interesting. So if you need any help with pulling up your presentation or anything like that, I will be on the back office. So if you need something, just ask me to join, and I'll be glad to help you. And before we start, I want to remind everyone that we will be having a survey in our chat. So please join that survey, which is provided by our sponsor, VU app, and we will be glad to have you in our chats. So if you have any questions, guys and girls, please go ahead and ask your questions to Agri, and we will be answering them during the Q&A section. So without any further ado, the floor is yours.
Okay. Thank you for your time, Paul. So yeah, let me introduce myself first. So yeah, I may share it my screen. Okay. So um, okay. Sorry. Yeah, you may see this slide right now. Can you see this right now? Oh
So
yes. So yeah,
we currently see just the black screen. So you're
just the
gonna
black
start the
screen.
presentation, yeah?
Okay, I already started the presentation, and then I think the it's only
So
black screen.
so we only see the black screen currently,
What about
and
now? Can
your
you see
cursor.
anything right now?
Nope, we see the black screen and your mouse, your cursor.
Oh, okay. Because I'm using the different browser on the trial session. Okay. If you don't mind, I would like to move to another browser. Changing
Yeah,
to
sure,
Firefox.
sure.
Yeah.
I'll be waiting for you here.
Oh, I'm so sorry for this inconvenience. I'm sorry. Okay.
Okay, let's wait a couple of minutes before Angry joins us. He needs to make some changes to his setup of the applications. He needs to switch to a different browser, and we will be waiting for him here. And meanwhile, let me remind you that one of our sponsors that joined us for this summit and who supported us was the VU app. And what they do, they actually help us to easily integrate user registration and management tool into our application. So go ahead, check them out. And this is something that will actually speed up your development process.
Okay. Hi Paul. I'm really
Hey,
sorry about before. Yeah,
sure,
I'm using
no problem at
Firefox on the
all.
trial system. Oh, thank you so much for that. Really appreciate it. So now I'm trying to share my screen again. Hope you can see it now. Okay. The screen. Yeah. Okay, can you see my screen right now?
Yes.
Okay.
Hooray, now we can see you. Okay, so the
Okay.
floor is yours. I'm on the backstage.
Okay, thank you so much for everything, Paul. So yeah, hi guys, my name is Andrey Ronald. You may call me Ronald. It's been weird since my parents doesn't really understand English, so he gave me the name of Angry. For someone who doesn't really understand English, Angry is a quite good name. So yeah, I'm glad to have this kind of name. Yeah, by the way, I'm a lead software engineer in PT Pevas Teknologi Nusantara. And yeah, it's about me. You may contact me using this LinkedIn account or maybe email, or you may see me on my GitHub account, but I'm not. Um, yeah, I pretty much contribute on the private repository from my company that I work for. So you may see just simple things in there, simple things. Okay, maybe we can move to the agenda. So today we are going to discuss about migrating the monolith to the microservices. So the first one we are going to discuss is identify whether it is necessary to be done, and then the second is how to migrate monolith to microservices. So it's pretty much the practical things to be done, to be prepared, and anything, and then the way we the way to tracing issue in microservices, because it's quite different and it's quite more complex to tracing the issue in the microservices instead of the monolith architecture. It's pretty much like how to troubleshoot problem in production states, for example, and how to handle issue with temporary solutions. And there is another consideration that I might found it's pretty much useful for you to know whether before you implement the microservices. So yeah, let's begin um, our presentation today. The thing is, monolith is, I think that you already hear about the monolith. It's commonly used right now, but we are moving to microservices right now, which is, for example, there is like monolith is already contains the whole business model, business logic of your application, of your um, system, and then you are going to migrate it to the microservices, which is you need to take in the specific domain service out and then create a new separated services. So, for example, the order service, payment service, and then the customer service. That's, for example, that's what we are going to discuss about right now. So, microservices having a lot of advantages. We can leverage microservices to get the more reliability. What is called deploy is like independent deployment, and also you would like to be your team more agile, and in the product development we can leverage this kind of architecture because it's already separated into product domain. So the team may focus on the order service, for example, and customer service and the payment service. So we have a parallel sprint that we may have on our teams, and then to deliver the whole feature together. So, for example, there is a two feature going to be developed for the order service, and the two feature going to be developed in the payment service and as well as the customer service. So we can deliver whole of them in the same time, in the same development time, I mean like that. Yeah. So the first thing we need to know is it necessary to be done? So we need to think about have you understand about the microservices, because you need to know about the microservices, about the pro and cons. Whether you move from the monolith to the microservices, there is always a trade-off, and you need to understand better about the microservices, because maybe you get some advantages, but you also may face another difficulties when you're moving to the microservice architecture. For example, the distributed transaction, and then the scalability whenever you still in the synchronous microservices, and then there is like the data problem with the data whenever you would like to improve the availability, and then the cascading failure that you need to be avoid when your services it depends to another services. So when your service depends to another services, and another service is going to be down or slow, and then you need to overcome that kind of difficulties, that kind of problems. And then you also need to think about you need to consider about your manpower. If you are on a small team, it is good enough to implement the monolith for the beginning before you move to the microservices, unless you have enough manpower to move on. Because whenever you already move to microservices, it means your responsibility become bigger, because the services that you need to handle is pretty much become more. So you need to have a spatial. I mean, like you need to have another manpower, another engineer to handle another services, for example, like that. And then you need to know about the business model. So this is pretty much the things that you need to consider. So, for example, like this, you already define the bounded context. For example, like the order service and payment service and customer service and the catalog service. So the catalog, that one service that you are going to take out and create a separated services. And then you need to see whether this business model on the catalog is already mature, because if not, and then you have a lot of features need to be related, need to be developed on that kind of services, which is might be impacting another services, or maybe another services have another feature need to be developed that have impact to that services, and then it's really hard to maintain because every time the other services, the other teams work on another feature, and then your team need to take one of two of another things to as the impact of their development feature. So that's for the example. And also you need to consider because it is very dangerous to implement the microservices, to migrate to microservices when you have a lot of backlog on your on your current sprint or maybe the next sprint. So you need to consider about that kind of thing. You need to discuss it a little bit. So that's the next thing. It's like a backlog. So you need to think. You need to discuss. You need to negotiate with your product team, with your stakeholder before you move to the microservices, because migrating to microservices is taking a lot of effort to be a lot of effort, and then yeah, it's taking time. You need to prepare something before you do it, because if not, and then there's something that maybe a disaster later. Yeah, let's see. It's we will going to discuss it later on. So, and the last thing is about the prioritization. Is it? I mean, like is it need to be done by now? So remember that you might have. So here's what a question that might simplify the things that I've made this for you. So yeah, I have this kind of memo in my other computer. So yeah, you have another question. So yeah, for example, you have a big team right now and running parallel. For example, on the same repository, it's no matter in the same repository. For example, monolith, it's supposed to be monorepo, and then you have a big team. For example, you have two big working on the same service, working on the same system, working on the monolith architecture, monolith services. And then, for example, it's on the catalog and payment. And right now, you would like to, if that's the first question. So let's focus on the question. I'm sorry. So you're having a big team with a parallel sprint, okay, running together, and then you are having a lot of issue with the changing impact. So there's another like domino. This is one. So because you are working on the monolith architecture, and then um, one team may deliver something on the sprint, and then after they delivered something, and then after they merge, after the pull request is merged to the master branch, and then you found out there is a lot of impact you got on your part, on your on your team need to be handled to fix before you can deliver your own feature. So you need to if you face this kind of problem right now, that's some kind of sign that you face. Okay, maybe okay. Yeah, you also having difficulty to deal with the deadline. So after that, it's also like a domino effect. It's also affecting the deadline, because the first team may deliver in on time, but the problem is when they deliver their feature, they deliver the services after they merge after they integrate their changing to the main repository, and then deliver it to the production stage. And there is a lot of change, and then you need to work on the change to overcome the impact, and then that cause you to missing the deadline. So there is another problem. And then yeah, if you found this kind of problem right now, and then you are in urge to move to the microservices, because there is a lot of reasons why we move to from monolith to microservices. But if you face this kind of problem right away, and then from our experience in Pavas, we found that this is hard to be handled, because if you keep in going with the monolith architecture with multiple teams working parallel, and it might be stressful to handle the pressure. the changing impact, and then maybe you lost the trust from another stakeholder because they may think this kind of simple feature you may deliver only on one sprint, but what makes you missing the deadline? What makes your teams not able to deliver it on time? So yeah, there is a lot of problem, but this is the sign that you are in urge to move to the microservice architecture. So yeah, let's discuss to the main point, how to migrate monolith to microservices. So the first thing is we are going to discuss about the non-technical issue. About the non-technical side, I suggest you to do some research about the microservices, about what is pros and cons, and yeah, you need to understand. I have a lot of lists in here. So the pros in here, you might got the independent deployability because you may deploy the payment services without thinking about other services because you are already independently put separated. So it's already okay to be delivered only on your services. So it's okay. So it's you got the independent deployability advantages, and then the second is data separation and isolation. There's a good things to do, but it's also becomes a problem later on working on the what we call consistency and the speed of the development time. It's of course the main point to speed up your development time, because whenever you already divided into separated into several teams, and then you can boost up your development time. It's a really good one. But the problem is it's not that simple. There is a lot of problems, scalability, for example, and because for the things that I said earlier about your services depends on other services, and it's also about the data because the data is already separated. So whenever you would like to collect another data from, for example, the product and then the customer, for example, order and product, and you need to call the product service to get the data, and you may seem it's just fine for the beginning, but maybe when you have a lot of data and a lot of traffic coming through, and then it's going to be disaster. And so I suggest you to learn from other experience by joining conference or watch the conference on YouTube. There is a lot of conference you may find on the Geekle, on the Geekle, I mean like on the Geekle, and then also there is a go-to conference. A lot of conference you may see. There is a lot of speaker, for example, like Sam Newman, Martin Fowler. They discuss pretty much clear and really having a really good presentation, so you can understand better from their experience. There is always two way to learning something. Learning from others' experience is giving us more advantageous benefits to overcome their problems, their difficulties that they already face on that experience. So that's the thing. And understanding the capture, this is about the consistency, availability, and partition tolerance theorem is really may give you a huge benefits to design the right microservice architecture that you are going to apply. It's really help us in designing our architecture. So move on to the technical things. So the technical things, we are start by implementing modular monolith for the beginning. So the first thing that we need to migrate is we move to the modular monolith, and I'm sorry, I got distracted. I'm so sorry. The first thing that you are going to do is separate the business context. It is like creating the bounded context of your services, of your system. Your system may contains a whole business model of your company, of your application, of your services, of your system, and then you need to divided it to make the bounded context of the according to the business, because we need to reflect from the product team. So for example, like a sales order and catalog, and payment and customers for the domain service that we already decided to move on, to separate them. And then after that, you need to prepare for data separation. So for example, sales order will contains the whole data for the order. But the problem is order may contain the customer's data. So customers need to be replicated to the sales order. So the data on the customers might be replicated on the sales order. But the problem is we only we only declare only the necessary data, so not whole object of the customer, because later on when we already separated the customer services out of these services, and then we only need to know about the data, the necessary data from the customer. So we don't need to know about the whole object of the customer, the whole data. So we need to prepare for the data separation. And then the next thing is to overcome the problem with the distributed transaction. So before we migrate, we need to know about the how we manage the problem with the data distributed transaction. For example, we create an order in here. There's a create order request comes to the sales orders domain, and then sales order domain will call the service on the stock to subtract the stock, and then call the payment function on the like payment service on the payment context in here, payment domain. But it is failed, and then you need to know how to handle it with monolith, and then also how to handle it when you already move on to the microservices. It's not easy because you need there's always two ways to overcome that kind of thing. Working on the consistency, we can using the two-phase commit or saga pattern. For example, for everything failed, every process failed will trigger to roll back the other process. That is the main thing, the main concept of the saga pattern. You may use the choreography or orchestrator concept in implementing the saga pattern. In here in PEVAS, we in our division, I'm in commerce division, we are implementing saga pattern in choreography concept. So it's pretty much like a stack. So for example, later when we okay, so just focus on here. So for example, the sales order is already a service, stock is already a service, and payment is already a service. So when the request come through the sales order, at the beginning, when we still implement the synchronous microservices, we we push the event after the order is created into the queue. Whenever we would like to call the stock, so we put it into the queue as well. So and whenever we would like to do the payment, we put it into the queue. So everything is already in the queue. And when something went wrong, we collect from the queue and then do the rollback from that specific event. So for example, this is failed, and then we collect from the queue, and then we roll back the process on the stock service. It's the things that we use at the earlier states when we, in the beginning, we migrate to the model microservices, and it works just fine. But it also having another problem. We may discuss it later on. It's really good to discuss about this kind of thing. I really love it. So next thing is about implementing the right method to produce lock among the services. It's not easy, especially dealing with the lock. Don't just underestimate about this kind of thing, because this might come in handy whenever you already move to microservices, especially you would like whenever you would like to trace an issue, and you need to know about the log. So you need to work on your logging process, because you need to change your logging process. It's not going to be like the old way whenever you're still using the monolith architecture, because the logging process, for example, in us, we are implementing the concept of the transactional outbox for our logging process. So every time the request coming through services and then going out to another services, we write the log we write the every request coming through and every request going out, along with the header, along with the object, along with the whole data that we need to be writing, that we maybe need in the future. That's the thing we are implementing here. So it helps out a lot whenever you face another problem with another services, and then you may it's also able to help you to reproduce the issue again, so you can find out the root cause for any other problem that you found. Okay, that's the simple things. There is another, another library, another services that you may use, or another product for the log. It's a lot of things that you can use. You don't need to, experience what we already experienced, but our experience here having another advantages. Maybe there is always a trade-off. Yeah, the next thing is we might move to the separate services. So after that kind of thing, that now we are focusing on the separating services. So for example, we have the modular monolith in here right now, and then we can take out the sales order service, sales order domain, and create the services for the sales order, and then catalog for the catalog services, and make sure it's for us we have the ideal thinking. We prefer to use separated database, but it's up to you to using the shared database as well if you want to. But shared database, it's not really recommended from us. Maybe we can discuss it later. And preparing the independent services, and then you need to decide the communication way between the separated services later on. So for example, you are going to implement the gRPC or HTTP call, maybe a RESTful with a RESTful method, and then or maybe message queue or pops up, or maybe you can leverage both of them, such as an SNS and SQS, like the Amazon already uh, Amazon already give us an option, so we can leverage that option. And then that you need to make sure your test is strong, because yeah, whenever you are really checking out another services, uh, you need to cover the QA test case in your test, because you are not going to be confident enough when you are moving it, when you are going to deploy it, if you have not if you have not your test is not strong. It's not really easy, so you need to make sure that you have a strong test, unit test, integration test, end-to-end test. Yeah, you may choose integration test and unit test. Maybe an end-to-end test is a must for yeah, for me. I think it's a must, from my opinion, because whenever you already move to microservices, you might expose your endpoint um, in exchange for your function call, because another service may call your separated services by endpoint call. And yeah, for example, the endpoint. If you are using the HTTP, for example, and then you may call it's using the HTTP call to your services, so you need to cover the end-to-end test as well. And yeah, on separate services, no need to rush, and you may separate the most stable domain into new services. So, for example, there is a lot of changing in your sales order domain, and then maybe the product team is um, planning on changing the business model on the sales order domain and on the customers. So don't separate them right away, because they might affect a lot in the sprint. There's a lot of coupling in there, tightly coupled. So whenever you change something and it's related with the business model, it's always affecting another things. So taking the mature domain, so you can take it and it's really easy to maintain later on. Okay, the next thing is about the deploy separate services. So yeah, have you ever heard about the? I'm sure enough that you are aware about the blue-green deployment. It's really good advantages if you already understand about that kind of thing. So if you're not understand, and then we are going to discuss it right now. So yeah, we you just follow these points. So deployed services, make sure the endpoints in your separate services are well managed. So if you are deciding to implement the API gateway, and then you need to make sure that the whole endpoint is already registered in your API gateway service. If you are not, and then make sure that the path, that the URL is already root from your for example, the load balancer, or yeah, routing that you already need to divide. I mean like you need to decide the route. For example, um, domain.com. I might share my. I might use this kind of medium to have a better understanding. So, yep. So, for example, you already have a domain.com in here, and you decided to separate your services, for example, the customer. So, make sure that the endpoint, that the path, customer path, will go to the services. So, you need to make sure that kind of thing before you move. And then make sure you have test your current application in development stage with separated services. So you already deployed the whole services along with the separated services on your development stage, and make sure the things is already running well in there. Your application is running well and everything is already under control. And make sure you have created the step-by-step process in deploying these new separated services. Make sure you have okay, I will discuss it later on. And the thing is, I will just discuss the last point before we got back to the third point. So make sure you have prepared for the risk mitigation on rollback everything when something goes wrong. So I may showing you about the blue green deployment. So it's pretty much like this. So for example, you have already in the server, and oh, it's different. I'm so sorry. So this is your wait. This is your current production environment. So this is the current production environment here in the left, and you may already having like a monolith architecture in here right now. So it's like a monolith service, and then you already prepare another environment with the um, production production environment already declare on the surface. I mean, like you already prepare for the VM for the you already prepare for the VM, or you maybe if you are implementing the containerized tools, and then you might having a container more than multiple containers inside one VM or anything that you would like to work on. So in here, for example, the each services located in separated VM, separated server. So for example, you divide it into A and B services in here. And then if you already, so this is it's like a blue-green deployment service. This is the green. This is the going, what we call, on um, on migration. Maybe we may say on migrating process. So your request coming through, you may divide the request coming through your services. For example, you may divide it into 75, 50, and 25 percentage. And this one is also 25, 50, and 75. So it's like a portion. So for the beginning phase, whenever you release your microservices, you put your load balancer and at the scale of 25, for example, and then the 70% is still redirect to your current services on this current VM. So it's pretty much really able to make able to handle the deployment in a good way. So whenever something went wrong, and then you just need to taking this service, or maybe you can just need to change the load balancer proportion into the 100% move to the current production EMV and working on the issue on the microservices right away. That's the blue-green deployment will give us a lot of benefit to in order to especially migrating to microservices, especially in the deployment phase. I'm sorry about this. Okay. Okay, so yeah, and now we are going to discuss about the way to tracing issue. Oh, I just have another 9 minutes. Okay, I'm going to a little bit fast on this kind of on this topic. So the on the tracing issue, how to troubleshoot the issue? It's pretty much harder to do in the microservices. So um, you might not be implement Grafana right away, or maybe you already implemented Grafana, maybe to visualize things. So collect the data from your log on from your other resource, and then visualize things in your Grafana, and then you can monitor right away from there. Or maybe if you are still in the beginning phase, in the early states, and you may leverage this kind of feature. But in the first thing that you need to prepare is make sure you have installed the profiling feature on your services. For example, because we are using Go in here, we are need to implement the Go with we are need to implement the pprof. So we are exposing our pprof HTTP server on for our services, and we can just hit on that port, on that exposed port for the pprof, to get the idea about the request coming through, about the memory, about the any other things, about the error rates. There is a lot of info you can get from there. And then you can leverage the feature on your database tools. For example, we are using the before. In the before, we are already having like a session manager and locking manager. So you can leverage that kind of tools to overcome, to have an idea, to help you to get an idea about the issue that you are facing in the production or in the staging or in whatever stage you face right away. Because for example you got an issue with the slow performance, and then you may see on your database tools, for example session manager, log manager, and then you might have an idea about the what is the slow query, what is the query which is slow query, and then you can work on it, or you may adding another indexing or denormalize the table or anything else, or you may found the locking because it's easily comes up, um, especially after you separated the surfaces. But you may yeah like you may consider about implementing the pessimistic or optimistic lock, but it depends on your situation. So it's always depends, because sometimes optimistic is going to have a lot of advantages, but pessimistic is also having its own advantages. And make sure your logging process is able to trace the process which is coming in and out of your services. Also producing the curl command if CRL, if it is possible. It help us to retry having like reproduce the issue. And make sure to have login process in your database when everything changes in your table. For example, we are having a lot of logging in here, logging that coming in and going out from our services and what happened in our services. There's another logging for what happened in our services, and also there's another logging for what happened in the database. So before the data updated and after the data updated, along with the yeah the updated data. So we store a lot of things to prepare, and it's help us. Okay, before we move, it helps us to roll back if the things go south. Okay, so move on to the troubleshoot. So another 5 minutes. Okay, I'm so sorry. Understand when is the error occurs, how the error occurs. It's what is trigger the error, and where is the error happens. Is supposed to be in your mind right away whenever you face any other issue in your production state, whatever state, wherever state you are um, handling right now. But you need to have in mind that you need to understand when is the error occurs. You need to know when is the error occurs, how the error occurs, what is the trigger the error, and where is the error happens. So there's always a two approach about this one. It's a bottom up approach. It's like when you are know what is happening in detail. So You have an idea about, oh, I know what is happening. It's happening in these services, and it's about this kind of problem. And then it's easy to overcome this kind of approach because you already understand what is happening. So you just need to generate the curve of the request coming to your services, and then check your log, or we called it reproduce the issue. So this first is just reproduce the issue. Check your log to make sure your assumption is right. So you need to check your log, and then try to reproduce the request in your local machine. Even debug if you have difficulty and understand the detailed issue of it. But not really recommended doing this kind of thing. But it helps us a lot to uh, yeah understand about the things in detail. About understand about the issue. And there is another like top-down approach. It's the hardest things because you don't really understand about what really happens in your service right now. So the first thing that you need to know, you need to it's always good idea to have a notifier that might notify you. So the issue is comes to you right away after the customers face it, or after the users face it, before the customer service get it from the user. But sometimes we got it from the customer service. um, so you also need to have like a health checker, health notifier. It's also help you to understand about these things. But let's discuss about this kind of thing. So if you got the issue from your customers, and then customer service, and then you need to know about the error code, or what kind of the error the customers got, whether it's not responding on which page, on what's button on, yeah. And you need to know about the error. After that, you need to analyze the issue. You need to have in mind that issue may related with the other dependent services, other dependency like caching, database, message broker, and any other um, your dependency. And maybe your service is down, your memory, there's like a memory leaks, communication medium. There's you need to have in mind that kind of thing. And then check your service status, is it up or down. Check your memory usage in your cloud service. But it's also you need to know, the first thing you need to know is the issue that the face from the that's faced by the users. It's sometimes give us a clue about the issue. Check the profiling data to know about the number of traffic and the endpoints. Check your database logging tools and any other and session tools. Check your log of the possible entry service of that error. So if you already know that this error is already arrived into the services, that you need to check the log, the incoming log. And after understanding what might happen in your services, do collaborate with your team regarding about the producing issue in your development stage to have a better understanding of the specific failed request. If it is hard to reproduce, I have another suggestion here, but it's not a really good one. The third one is not a good one. So you may create a scenario with isolated condition in your production states to try to reproduce the issue and fixing it right away. You need to be able to create the same requested isolated condition, or maybe the last thing you might need to do is, if you having difficulty, you might even do debugging on your IDE with the production environment. So your local is act like your production state service and start by reproduce the request to call your local, and it's not recommended. If it is a crucial error, you may put a maintenance mode on your services and hurry to solve the issue, since this may affect your availability. Yeah, it's like a catastrophe if you found this one. If the root cause is not able to fix in the short amount of time, after implementing the temporary solution, find out the root cause of the problem. Set up a meeting with the stakeholder and discuss whenever about when you are going to solve the root causes, and then explain them about the problem. Create a postmortem document is helping you to helping the team to overcome the issue if it's comes up again later on. So I'm really sorry. It's already over my time, but I'm going to be fast on it. So how to handle issue with temporary solution. So about the problem with the slow services. So these slow services, I have two simple issues that you may use. It's like a API caching. It's you cache everything on the Redis, and then whenever it's still not expired, you might take from the Redis instead of calling to the logistic services. And you may use the circuit breaker. So, but it's not really good. It's not really recommended because the circuit breaker is having like a request volume threshold. So we can whenever the request is already, I mean, like huge amount of requests coming through on your services, you may stop another request and then act like the service is okay, but it's not actually okay because it's not. I mean, like for example, you click a button and then it's nothing happen. It's nothing happen. It's nothing happen. It's but at least your service is not done. It's not a good thing, but it's can be used. Okay, the other thing is like probably the down service. So on the down service, you can use the circuit breaker as well, and you can set up the threshold, and then you can use the message queue with the retrial mechanism. So you can just publish it to the queue, and then you have another worker um, retry on the calling the payment service. So the process in the sales order is already done, and you may have another status, for example, waiting for payment, and it's much better. So the user didn't have another what's called user experience issue. Okay, and problem with slow query, you may optimize the query, adding index or denormalize table when needed. Another consideration that you may come in handy is like implementing domain-driven design. Is help us to yeah uh, help us a lot in divided the separated the bounded context. Implementing the solid principle dependency injection especially it's really useful. Secure as common query responsibility segregation is really the things that we need to implement later on, but it's really come in handy. Maintenance mode, Docker or any containerized tools, it's really help us. Denormalization, denormalization or versus API build service. Maybe later on we can discuss about it. CI/CD, shared database, separated database, eventual immediate consistency, consumer-driven contracts because endpoint contracts. Because whenever you change you need to really have in mind that your services can be accessed by the endpoint you expose. So the endpoint it will be like the contract. If you change the endpoint without telling other services, other teams, you break the contract, and the other services will going to be having difficulty to hit your services. And you need to having like API documentation is really need to be have such as OAS Open API Specification 3.0 right now. And maybe that's all I can tell you about right now. I'm sorry for taking too much time. Maybe yeah.
Hi. Angry, no problem. Thank you. Thank you for the amazing presentation. Thank you for wrapping such a massive amount of information into and squeezing them actually into those 40 minutes. So thank you for that. And I guess we're gonna have lots of questions. We're gonna have lots of discussion in the Q&A section. And I will add. Thank you for now, and we will be waiting for you during our Q&A section. And I will add our next speaker, and it's going to be Satyam Pandey. He is Senior Chief Engineer at Samsung Research, and he will share with us some practical approaches for breaking down your monolith system into microservices. Hi, Satyam. Thank you for waiting for us. And yeah, we can hear you. Thank you for graciously giving us another 5 minutes to wrap it up. And I guess without any further ado, I'm just going to add your presentation to the screen, and we'll just start. And let's go ahead with your presentation.
Sure. So hope everyone is enjoying the conference. And previous session really it was having lots of information, and I hope people will have lots of question and answer. So for the ado, let me start my presentation. So I'm mainly talking about what are the approaches we can take whenever we are either designing microservices, either it could be greenfield or we can do a migration also, right? So my whole talk will be around this. And just to give quick introduction, I am Satyam, and I am Senior Chief Engineer at Samsung Business Bangalore. And you can follow me on Twitter, and this is my LinkedIn. And I generally enjoy building and joining the community around software design, architecture, even product side also, because I love to listen, talk from the products people. And from recent couple of years, my interest of area is on the microservices, including micro front end, because I love full stack. So I will always try to look towards the whole system. So for me, backend and front end, that comprises of everything. And definitely, if I'm trying to do all this thing, I love to talk about it. So today presentation is for the microservices part. So let's go ahead. And this will be my agenda. So I will be talking in and around these areas. So we'll be talking about how we can do the migration from the monolith, what are the designs, principles, and patterns we have. We will touch upon event-driven system also. And at last, I kept it separate. I will try to touch upon event modeling because that is something new, and I'm really excited to share whatever I know on that part. So if you take, because it's very generic application, I hope everyone have seen this, and even in all the talks, at least e-commerce is quite popular. So let's take a monolithic application where I have my UI components. It's a login, search, I'm having a card system, I have a payment, and I have a shipping. To support those functionality, I will have API layer, and I can have API in and around login, search, card, payment, and shipping. So just take this as a reference because throughout the my talk or throughout the presentation, I will be taking this as a reference because this is our monolith, and I will have a single data store. And generally, this is the flow. Like if you see any of the monolith, and if I'm talking about tiered architecture, generally this is the flow we have. So what we have is my presentation layer will receive a request from the end user, and mainly it's kind of HTML form. Suppose user is using a form system, and in the presentation layer, my JavaScript is going to process the form and execute a call to a business layer. And once it comes to the business layer, then it's going to process all the data collected from the previous layer, and then it's going to make a query and using the utility layer which came in between here. So in case of tiered architecture, this is the generic flow we have: presentation, business, utility, and the data layer. Here the data could be either you are using relational like MySQL or not relational like Mongo, so it could be anything. Now this is how generally we think about a monolith, and which is having in-tier system. So before migrating to microservices, we should think about why we need to migrate. Because generally, if you see the stakeholder, it's not only developer. You have a product team, you have QA team, you have design team, and then we have dev team also. So whenever we want to migrate to microservices, it should at least have either few of them or all of them as your problem cases. So first thing could be it should definitely have some measurable business impact. So let's take our example of e-commerce. If I'm going to expand it to let's say multiple country or multiple region, I will have lots of users who are going to use my system. And if I'm going for microservices, if I'm able to reduce either my page load time or if I'm able to improve any of those areas, then definitely it will impact my business. Second is scaling out the system during high usage. So it's dependent, like whenever we have specific days, like in India, we have big billion day sale or prime day sale, right? So in those days, there are many users who are going to use our system. So how we are going to scale the system during those high uses? So it could be very specific from system to system. I am just giving some general example. Third could be the code dependency. Suppose you have huge monolith and you have lots of modules. So whenever you want to add a new feature, you need to look around all the dependent module which is getting impacted because of this new feature. One more point, I have seen like generally people ignore this, but time for onboarding new member, it's really important for me, and I've seen it should be important whenever we are developing a system. So for me, onboarding a new member could be measured, let's say if a new developer is joining my team or if a new developer is going to build a product. It could be it's as generic as the 10th commit whenever he's going to do that. So that could be the time of onboarding for any new member. And if you are facing a problem in monolith because you have lots of module, lots of code, lots of dependency, and onboarding of new member is suppose a critical thing, definitely you should look on the microservice part. Next is the release cycle. So generally, if you see the monolith, the assumption is it will have at least release cycle of a few weeks to few months. And if you go for waterfall approach, it could be once in 3 or 6 months also. So generally, if you want to build fast and deploy fast, you should look on the microservice approach. Next part is find and fix the problem, because if you have microservices, you are very specific, have the end user systems. If there is a problem, definitely it should be easier to find the problem. And if you are able to find the problem easier, and if you have lesser release cycle, it's lesser time to release it in the production also. Last but not least, technology agnostic. Nowadays, because my system should not be dependent on any language, and we should embrace the language based on its capacity. So, for example, if I'm using Node.js or TypeScript or JavaScript, and if I'm having a use case for any data related part, I should be able to use Python. I should not totally dependent on few languages. So based on the microservices capability, we should decide the language, and definitely it will help us to become a polyglot. This long run. And these are the generic principles we use whenever we are designing microservices. High cohesion along with loose coupling, so that whenever two microservices are there, I should not have tight couple system, because if I'm having tight coupling, at the end, actually I'm building a big monolith, which I again creating problem in the later stage. Every microservices should have API, so that anyone who is outside of system or even client can use it if I'm having a API integration seamlessly. Unique source for identification, because whenever I'm building my microservice, definitely I need to have some service to identify my services so that I can redirect my client to a specific service. And then we can have the real-time traffic management, because when we grow our system, when we have lots of microservices, this real-time traffic management system could become a crucial part. And then we need to minimize the data tables to optimize the load. As per microservice concept, each services should have own data store. So definitely we need to minimize the table which is having more dependency and which are getting more loaded. Next is performing constant monitoring over external and internal API. As we have broken down the system, we have lots of services. So it's good to think on that front from the starting, because if you don't have a proper logging and monitoring system, it will be really difficult for doing the log aggregation or again identifying the issue later part of time. And next we have the isolated data storage for each microservices, so that we can have the bounded context, and the decentralization system. So here the First and foremost principle is whenever we are designing a microservice, the ability to break down the monolith into separate individual entities. And whenever we are calling these entities as microservices, it should work independent of other system functions and all user to edit, delete, or employ any functionality without affecting the system performance. Last is scalability. Microservices are uh, the major reason why we want to go for scalability part, because individual microservices can be scaled based on the usage. And here we can again go for multiple approaches, and we can design our guidelines based on the scalability part also for each and every microservice. And these are the generic design patterns we have whenever we want to go for a microservice. So we have in case of effective collaboration, we have aggregated pattern, and yeah, the aggregated pattern is, let's say we have multiple services, and fetching the output and combining the data uh, for the end user is necessary. So whenever we want to combine data from multiple services, we definitely need this aggregated pattern. Similar to that, we have branch microservice pattern. So they are basically the extended form for aggregated pattern. And here you can simultaneously process the request and response from two independent or two mutually exclusive services also. Third is backend for frontend. It's quite popular nowadays because GraphQL is hot topic in this area, and mainly maximum companies are moving towards backend for frontend, because fetching data from every running service is imperative of any application. And with the microservices architecture, it is really important to extend the data from individual services, but fetching the user own resources from the variety of microservices based on the UI. Let's say if I'm having mobile, if I'm having desktop, maybe I'm using the same application, but I need the different set of data. Or maybe in mobile, I want to have lesser data because my view or code is quite less. So it's very useful whenever you want to segregate the application based on the devices or based on the client. Next, we have the performance monitoring. So here, mainly we have these two kind of patterns. Log aggregation, which I think it's quite obvious. We need to aggregate log from each and every services, and to track the numerous services log, it's always a best practice to have a proper system, so that if you want to analyze or if you want to find any issue, you'll have a sequence of logs across the services. Next is your API health check. So when we have lots of services, it's good to have this API health check system, so that in case of down of any microservices, my other services could behave or could have some fallback mechanism, so that my user should not get much impacted. And it can be due to many factors. It could be because of load, server load, maybe because of latency, maybe because of error logging. So API health check is, I would say, it's must whenever we are going for performance monitoring part. In terms of business capability, definitely services would have unique business capability, because that is the main crux behind domain-driven design. So whenever you're building a microservice, each services should have unique business capability, and that is the way we are going to decompose a bigger software system into smaller independent logical units. And whenever we talk about similar business capability, it's quite obvious. Like generally, when we go for micro level, it's very hard to uh, pixelize, or what I would say. It's very hard to identify like till what level I should go. I should go per API level, or I should go per functional level. So it's obvious to think on this part, like where we have the similar business capability, and it could even share the same data store. So we should think on similar business capability part also. Then we have the triangle wine pattern. It's a very popular pattern. I hope everyone have heard of it. Whenever we want to go for migration, this is the first pattern we apply it, so that my whole monolith system, which is user facing, and user will not be aware like actually I'm doing a migration. So this is, I will say, most popular pattern whenever we think about microservice migration. The fourth category could be on the storage part, how we store the data. So it could be database per service, which is very popular. Like whenever we want to go for microservices, it's advisable to have database per service, but still, I will say, because it depends in terms of architecture. It depends how is your use case. So if I'm talking my same use case of e-commerce, I have seen like there could be some data stores which need to be shared across services. So that's why the second could be the shared database per service. And here, maybe we need to think on that part, like maybe we can limit the number of services who are sharing the data based on the use cases. And suggested limitation is maximum two or three, because if you are going to share more than two or three services, actually you are going to end up building monolith system instead of microservices. Next is my event sourcing. So event sourcing, nowadays people are moving towards event-driven system, and event sourcing is one of the main part. Like if I follow the Martin Fowler, he's saying like event sourcing ensures that all the changes to application states are stored, so that whenever I want to recreate that particular state, I have my whole logs, and I can move from any events from past to the present part. So event sourcing is very popular nowadays, and especially when we talk about the client-facing system, event sourcing became de facto nowadays. Last is not the least. It's CQRS, and I have heard like in my the previous speaker also talked about CQRS. So I hope everyone is aware about the CQRS part. So let's rethink whatever we thought, like we are going to migrate the system from monolith to micro, and I'm taking the same use case. I have my search. So this is the general flow. User is going to search a product, and he's going to add it into the cart. He will go for payment, and once the payment is done, I'm going to set the product. Now, if you see, this is my generic flow. Like whenever I want to build the system using my traditional CRUD-based approach, I will have these kind of tables. One table could have my user ID, cart ID, and state, and second table could have cart ID, product ID, and how many quantity, and so on. So if I talk about the CRUD, this is the approach I'm going to follow. But nowadays, that's not what other people want, because in terms of product, we have many different stakeholders. So suppose my BA team or product team wants to know or wants to do some analysis. Generally, they will come up with questions like this: what is the likelihood of people who are trying to buy a product, and that they're removing from the cart? So let's revisit this page. Here, if I'm going for the CRUD-based system, this particular question I'm not able to answer, because for this I need to go for something called event source architecture. So event source architecture is kind of implementation of the event-driven architecture, in which we are going to store each and every changes. So whatever user is performing actions, each and every actions are getting stored, and it's really beneficial if you're going for customer engagement or doing some analytics or ML or AI thing, or even it's useful if you're going for some security or compliance audit. So event-driven system is kind of becoming a de facto because of this reason. And just to revisit how would be the life cycle. So currently, let's say I as an end user, I'm going to add some item in my cart. Then I will be going for cart created, items added. Again, I'm going to add item. And suppose I'm removing some item, I will have item removed also. Now, at last, I'm going to do a checkout. So here we can see, like, if I'm going for event driven system and event sourcing part specifically, here I'm actually storing even the item I'm going to remove. So whenever any kind of analytics I have to perform, I will have that answer like this particular item has been removed before going for checkout. And this is the way we are going to store it. Like whenever an event is happening, I can define the event ID, event type, what is the data, and what is the timestamp. And the current store is stored in the memory by applying the events as they occur. And as we can see, it could become computationally heavy because we are storing each and everything. But I hope we are in the era where storage cost doesn't come much in picture, because we have to have lots of use cases on ML and AI. So anyway, I have to again invest some more money on doing ML and AI part. So it's better to store each and everything so that in future, if I have any kind of use cases, I should be able to solve it. Here, things to remember, events is always a past tense, because we are going to store the events once it's happened, and events should only be created because here we don't have the create facility. I don't want to delete a event, and if I'm deleting something, that means I'm going to alter whatever user has done or whatever that flow was happening. And events should be broadcasted only within a bounded context. Here, generally, we have this command and events part. So whenever commands should be used, when we know what should be done. So let's say user has added a card, payment has been done. Now, once the payment is done, then I can execute a command for doing order, because the payment is successful. So on those use cases, we are going to use the command. And generally, event don't expect anything in written. We are just it's just a broadcast message, and whoever or whatever services, they are going to use it, and they can act upon it based on the requirement. Now, what's the next big thing? So this is my personal opinion. Like whatever flow we have seen, like generally the monolith to micro, and then micro to event-driven, event sourcing. So in my opinion, this could be the big thing. And I've taken this from Adam Dimitrick, and I recently started following him, and I had few conversations with him. So generally, whenever we talk about my microservices or new paradigm of architecture, this is how current structure is that I need to go for DDD. I will have lots of tool. I will have UML. I will have use story. But by if I'm having event modeling, I can at least solve all of them. This is what I'm also thinking, and Adam Dimitrick also suggests the same. So let's go ahead and let's try it out. Like, what is event modeling? And just to give a background here, generally when we talk about waterfall and agile, and if consider this is my bad drawing, and this is kind of a pendulum, and waterfall was extreme, and agile came, because in waterfall we have lots of problem, we have many failure of the system, or I will say agile was the counterpart for waterfall. So I'm also agile practitioner. I'm using agile for almost more than 10 years, and I will say like agile is having lots of good things, and still I will say we should follow agile, but event modeling comes in between. So I will say the best of waterfall and the best of agile is what event model is kind of trying to create it, and let's see how much we can leverage it. So this is the event modeling. So event modeling is a method of describing systems using an example of how information has changed within over time. and it's actually trying to do a right balancing between my user journey, wireframings, event storming, and design thinking. And it's actually invented by Adam Demetric, who is the founder of Adaptic, and with the help of Greg Young, who is the main corner for CQRS and event sourcing. So, in simple word, I will say this is what event model comprises of. So, in visual language, I can say it's having wireframe, it's having command, it's having event, and it's having view. So, whenever I want to design a system, I will try to have all these things in place. And in terms of patterns, we have four patterns. We have state change, we have state view, we have external state input, and we have external state output. Now, what are the building blocks for the patterns? So, at the core, generally, whenever you want to design it, due to lack of time, I won't go in detail, and maybe you can reach me out and we can have a separate follow up. But on high level, these are the four things I'm going to use it: input, output, automation, and translation. And generally that is the way, like if I'm having commands, I'm going to use blue boxes. If it's view, I'm going to use green boxes. So it's up to you guys, like how you want to design the system. But generally these are the four different block patterns. So here inputs or change of system are actually instructed by user. So whenever user is going to perform any events, this input is going to change. Here, output is kind of information provisioned by the system and requested by a user. For example, let's say automation for automatically initiating interaction with the external system, like payment gateways or something external like that. And automation is for automating other events, like once my payment is done, if I want to automate my order system so that it should start doing the fulfillment of that product, I can go for that automation. And fourth is my translation. And translation is for receiving data from external system. So let's say if I'm having incoming order from a partner company, and if I want to integrate, or let's say if I want to integrate with my FedEx for fulfilling of my order, I can go for this translation. And how to follow event modeling. So here, the best part with event modeling I have seen is generally when we develop a product, we need to involve multiple people. It's just not developer. We need to have design. We should have product people. We should have project managers. So whenever we want to design a new system, this is the way event modeling do. Like it will invite all the people, and it's almost similar to the ceremony we have in Agile. Generally, we do it for sprint or something. Here we are doing for whole system, because this particular event modeling is kind of providing me a blueprint of my whole system, which can be as easy to be understand from product team or QA team or dev team. And in future, if I want to modify anything, I'm going to modify my blueprint so that everyone should be aware of this. And right now also, yes, we are doing it, but I will say we are doing in silos. Dev team will have its own documentation, like generally, let's say I'm starting with UML diagram or something similar for my design. And I will say UML is very specific for developer, and it's for developer by developer. And similar to that, QA could have their own set of documentation, product could have their own set of documentation. So event modeling is trying to bridge that gap, and we'll have single grouping, which can be discussed across all the stakeholder, and which can be used across any stakeholder. And I think I'm almost near the time, so this is my 2 cents. So whenever we design the system, blueprint is more important than utility of the system. So utility here could be the kind of services that I'm going to use for implementation. Blueprint is my core system design, where I'm going to have how my system is going to interact, what are the components. So definitely we should always focus more on the blueprint. because once the blueprint is ready, utility could be dependent or independent. Let's say if I'm talking about serverless or something which is very specific to some of the cloud providers, then utility could be built on top of blueprint. And whenever we are doing a migration, it's good to migrate from mono to macro and then go for micro instead of going for a big leap directly from mono to micro, because that's how in my case it worked. We went first from macro, and then probably we are going to go for event driven micro services. The next thing is event-driven systems are the new normal. So let's accept it. We need it at least in many places. I will not say it's a silver bullet because let's say if you're going for some very specific high-intensive data analytics or some algorithm kind of system, but the places where it's customer-facing or user-facing, event-driven is kind of a de facto, and let's start using it. Event modeling, I will say it's a new paradigm, and let's give it a try. And definitely, I've seen the kind of company which are impressing, either it's Capital One or any new financial systems. They have built event modeling successfully, and they are definitely getting the fruitfulness out of it. So that's it from my side. Thank you. Hey Paul, am I audible to you?
Okay, thank you. Pavel is here. I hope you were not waiting for me way too long. I just saw thank you, and I'm like, what's going on? Is it? Are we done? Are we done yet? Aren't we?
Yeah, I think I almost tried to complete on time.
Yeah,
Sorry if I
yeah.
took
Thank you.
some extra 2 or 3 minutes.
Yeah, a couple of spare
And
minutes.
I have few reference in my slides. So if people want to go in detail, I will share the slides when the conference is over.
Absolutely. Thank you, and we will see you during our Q&A session.
Sure, thanks.
Thank you, Satyam. Okay, and let me introduce our next speaker, Havana Babay-Adi. Hi,
Hi.
Havana.
Hi.
How are you doing?
I'm great. Thank you.
So, could you please give us a quick introduction of what we're going to be doing today? So, I guess we're going to be migrating stuff
Yeah. You are going to
because
do.
that's what we were doing like the last couple hours.
Yeah. You will be migrating, and I hope that after this session you will get some tips and practical tools to migrate even better.
Okay, thank you. And we are super glad that someone with your experience being a software engineer and tech lead at Google, you joined us. And thank you for the experience that you are going to share with us. So I guess I'm just not going to populate the space anymore, and I'll just pass the stage to you. Thank you.
Thank you. Hi everyone. My name is Hava. I'm a full stack software engineer and tech lead at Google. On top of my job, I'm interested in public speaking, and also I'm managing a local community of women that are high-tech professional and live in my hometown. I'm very excited to take part in this conference and share tips from my experience, and also be inspired by the other speakers here. And let me start with a story. This is my first car, Hyundai Accent 2006. I bought it new, and I used it for more than 12 years. When I bought it, it was the newest model, and I was very happy about it. It served all my needs to drive from home to work and back. 12 years later, my needs have changed, and the car did not scale. I have 3 kids, and there is not enough space in the back seat for 3 child seats. In addition, there are more and more maintenance treatments for the car, which cost more and more money. Eventually, the air conditioning was broken, and I decided that it is too expensive to fix. On top of the scale issues, I decided that it's time to buy a new car. And then I bought a new car, Hyundai i30, because I really like the user experience. This new car satisfies my needs, its scale up to my needs, and I don't have any more maintenance issue. In addition, I have new features that I can use, like assisted parking. I've told you this story because I think it demonstrates the story of many migration projects. When you first implement a system, it is using modern technologies and it scale and satisfy all the needs. But as time goes by, maybe the system is causing issues, maybe it does not scale, maybe the technology is using is old or maybe even deprecated. And you must migrate your system to a newer one in order to keep it resilient and long-living. Migration projects are different from developing new features and new systems. The main reason is that you need to handle a migration while the system is live and handling traffic. Also, on migration, you need to replace the old system with the new system without compromising on the existing features on the old system, on its availability, usability, performance, and of course, data correctness. Can you write in chat, yes or no, were you involved in a migration project in the past? I will be looking on the chat on YouTube Live.
Yes, we definitely can do that, and we will be asking everyone to participate in this.
Thank you for answering, and I do see that everyone who answered wrote yes, and indeed, migration projects are an important part of our work as software engineers and as software architects. I've recently designed, implemented, and launched a project that was migrating one of our frontends. The frontend was implemented in gWT. Those of us who were software engineers on 2006 might remember that gWT is a framework for building web application in Java. We wanted to keep with modern technology trends, and also gWT have fewer releases these days, so we have decided to re-implement the front-end in Angular while maintaining full functionality and availability. In this talk, I will discuss a case study of a reporting system. Let's review the component of this reporting system. First of all, the reporting system has a user interface in which users log into and create reports or update reports. This reporting system also has an API that is responsible for all the CRUD operations and maybe other operations dispatched by the UI, and also this API server is using a database to store the report configuration. In addition, this system has a batch process. This batch process is responsible for generating the actual report data and email reports to recipients based on cadence defined on each and every report. Let's discuss a migration over this demo system. We would like to replace the UI into a new technology. I would like to review all the alternatives for such a migration project. When designing a migration project, you should aim to consider the pros and cons of all the design alternatives. So the first alternative is just replace the UI. Another alternative would be replace both the UI and the API. That alternative is relevant if the API is also implemented using a non-modern technology, or if the new UI technology does not communicate well with the legacy API. A third alternative will be to rebuild the entire system and basically ask the users to switch to the new system. In my case, we have decided to migrate just the UI in order to reduce the risk. However, the legacy API, we had issues connecting the legacy API to the new UI, and also the schema of the API was not based to latest standards. And this is why we've introduced another API layer that its main responsibility was to translate from the schema of the legacy API into the schema of the new UI, schema used by the new UI. In this session, I will share the lessons we have learned from this migration project, and I will share lessons learned for each and every phase in the project lifecycle. You can see here all the phases that I will discuss. My migration project was a UI migration project, but I believe that the tips and lessons that we have learned can be helpful for any migration project. And also, if you have questions, feel free to ask them on chat, and I will answer them at the end of the session or on the Q&A session. So, let's start with the design and planning phase. My first tip would be use migrations to bring new value. When planning a migration project, you should list all the existing features, and then you should try to understand what is the usage patterns in each and every of those features. You can do it by meeting with users with the help of your product manager, or you can do that based on the data you have on the existing system. For each and every feature, you should decide whether it should be migrated to the new system, whether it should be deprecated, or whether it should be optimized when implemented on the new system. In our example, we have realized that we have a mechanism for favorite reports, but it is not really in use, so we've decided to deprecate it. And also our permission model was not ideal, so we have optimized it in the new system. This analysis is also important when prioritizing features. We have realized that our reports are created and rarely updated, so we have prioritized the creation flow over the update flow. However, migrations are not just about replacing existing functionality with a new one. It's a chance to look for new value to bring to your users, and also build a system that is aligned with the multi-year vision of your group. You need to make sure the new system is aligned with today's needs, which may be very different from the needs at the time the system was originally developed. The new value a migration project can bring can be a new value to the end users or to the engineering team, or hopefully to both. In my example, we have realized that there is a set of users that could not use the existing system, and we have designed the migration project so one step after the migration, it will be possible to extend the system to support those users. This extension could not be possible with the legacy system, and it was possible with the new system. And that is the new value to the users. And for the engineering team, we have built a shared component that will later leveraged on other parts of the products, that our team was developing. Actually, the UI that we have been migrating was a side project, but after this migration, it became much more popular due to the new and large value it brought. Next, verify latency and volume requirements. Legacy systems accumulated large number of data. And this large number of data should be supported from day one. Large amount of data might have performance impact, and you should take that into account. This is opposed to new systems that launch with an empty database. So these are the questions that I recommend asking when designing a migration project. What is the expected QPS the new system should support based on the QPS of the legacy system? What is the expected latency? And what is the volume of data the new system should process? In my example, the main page of the reporting system had a table showing all the reports a user can edit, and for some users, this table showed 20,000 records, and it has the initial implementation of the table had performance issues and could not display this large amount of information, and it impacted our launch date. Basically, the launch had to be delayed in order to support those 20,000 records. Next, plan the data migration. You need to make sure that existing production data does not get corrupted as part of a migration. One of the largest risks in a migration project is basically corrupting data as part of the migration. This is not relevant to all migration projects, but it is very important for migration projects that convert data from one schema to another or from one storage layer to another. In addition, existing data may contain all records that are now invalid, however, should be handled by the migration. My recommendation is to create a plan for data migration that contains the conversion from one schema to the other, and also testing to verify this conversion. There are a few testing strategies we can look into. Those, I would say, the basic testing strategies. You should build unit tests for the data migration. You should build end-to-end testing and also perform manual tests of operations that are being performed in both the legacy system and the new system, and provide the same result. However, those tests are not enough because production might reveal edge cases you didn't consider or you didn't think about. One approach to do that, to mitigate that, is to perform an offline validation. This is the approach that we took. Basically, we built an automatic test that converted the entire production data from the old schema to the new schema and vice versa. And then we compared the data before conversion, after conversion, and made sure that it's the same. And if the data is not the same, then it's a bug in our conversion logic. Another approach that can be taken in order to find more edge cases using production traffic is the online validation. This can be done on top of the legacy system. Basically, on each operation on the legacy system, you can convert the data from the legacy schema to the new schema and vice versa. This conversion should be performed in memory. And if the original and the converted data is not equal, you should log the mismatch, and this way find more edge cases. Of course, in the offline validation, any edge case discovered in the offline validation or in the online validation should be added to your set of unit tests. Next, plan buffers. So you are migrating a system. Most likely that the system knowledge is missing. It's very likely that the developers who implemented the original system are no longer in your team or even no longer working in the same organization. In my case, none of the original developers of the system indeed were in the company. And also the people that maintained the code since it was originally written were no longer part of the team. We have discovered features along the way that we weren't aware of and were used and needed. And I would recommend plan buffers for unknowns, as in migration projects, it's very likely system knowledge will be missing. Additional parts of the system might also be not up to date. As I said, if you have a UI that is implemented with non-modern technology, it's most likely that other parts are implemented using modern technology. In my case, we realized that the authentication mechanism we used is not up to latest standard, and we had to optimize it as part of the migration. And this is another aspect that you should plan buffers for. The last, due to those two reasons, I would encourage you to start migrations early. Also, I've described earlier several alternatives for a migration project, and if you really want to be able to consider all those alternatives, you should start the migration early enough. I would say that this is as opposed to my car story, in which the air conditioning was broken. I had to buy a new car within a week. You should aim to have enough time to plan all the alternatives and not just choose the quickest one. Okay, so we've done planning our migration project. Let's look into implementing a migration project. Involve the user as soon as possible. It's very beneficial to have production traffic on the new system as soon as possible. It's more likely that you will be able to implement features and improvements based on user feedback early in the migration process. My migration project was a UI migration, so we had a monthly meeting with our top users to get the feedback on the new system. And also we have asked those top users to start using the system before we've actually launched it. In this process, we found plenty bugs and UX improvements. This is relevant also if your migration is happening behind the scene for some backend service. You need to choose specific flows that are relatively simple and migrate the traffic to the new system. And this way, understand the usage patterns, bugs, and so on. After implementing the migration project, we need to launch it. Ensure business continuity. You need to make sure that the user's ability to perform their day-to-day work is not being affected by the migration. For that, you need to plan a phased migration that can be rolled back at any time if needed. And you should also test your ability to roll back. I would recommend to begin with a small set of users and increase the number of users that are using the new system as you gain confidence in the new system. And indeed, this is what we have made in the front-end migration. More and more users used the new system, and where we gain enough confidence, we've switched the default URL to point to the new system. Users are not keen to move to the new system. You need to remember this when planning the launch. In my case, when we planned the release, we hope that those top collaborators that were using our beta version will use it regularly. However, they tried it once, found some bugs and some UX improvement, and continued to do their day-to-day work using the legacy system. The users didn't ask for this migration. They were happy with the existing UI as it is. And I've seen it happening many times also when I had to migrate from one testing utility to the other as a software engineer. In many cases, it was a project that was postponed to the very last moment because we were happy with what we have already. So in every case that a user needs to perform an action as part of a migration project, you need to find a way to encourage the users to use the new system. Ensure you have proper analytics. Basically, you need to have proper analytics both on the old system and the new system in order to track the migration. You need to make sure that you can compare metrics between both systems. Those are the metrics that I would recommend having. First of all is performance, to make sure that the new system system does not create any performance regression. I would recommend having an error rate also to make sure there is no regression. And it's important to have a usage rate to understand how many users are using the new system versus the legacy system. In my case, some of those metrics did not exist in the legacy system, and as part of migrating to the new system, we had to implement some of those metrics in the legacy system. Okay, so we've planned our migration, implemented it, launched it, and now it's time to shut down the legacy system. In my case, it took over a year to shut down the legacy system. This is because when we launched the new system, it satisfied the needs of 80% of the users, or even 90% of the users, but there were 10% of the users that their use case is not in our mainstream. And it took time for us to implement it on the new system. And while the system was launched, and we have celebrated the launch, new projects came to the team, and we started working on them. My main point here is that as software architects, you need to make sure you don't remain with two systems. You need to make sure that although there are new priorities and new projects after you launched the new system, there are still some work being made on the legacy system in order to be able to shut it down completely. Okay, that's it. Those are my tips for a migration project. I would list here the three main tips that I think that are most important. First of all, migrations are a great opportunity to re-architect and bring new value. I would recommend to plan performance tests and data correctness tests, and also make sure you have proper analytics. So thank you very much for listening. I hope the tips I gave will be useful in your next migration project. I hope to see you on the Q&A session, and also you can contact me on LinkedIn for any other questions. Thank you.
Okay, thank you for your presentation. And our Q&A session will be starting in, I believe, in around 15 minutes. So I guess we will take a quick pause for that. So we will be gathering for the Q&A, for our Q&A session at 20 minutes past 3, I believe. That's same time at your place, I guess. So yeah, in 15 minutes, we will be joining our Q&A session. And right now, I will have some short announcements. So thank you, Hava. I'll notify you when we are ready to roll out the Q&A session. And thank you once again.
Sure.
So, and before we go to the break, I want to encourage everyone to participate in the survey that we posted in our both of our channels, in our YouTube chat and also on our platform. And when you participate in this survey, you will receive a free 1-year license for the VU app. And what it actually does, it gives you the integrated registration and management tool. So basically, you can concentrate on development, not creating the functions that you can actually get as a pre-developed API. So you can concentrate on those functions and the ideas of your project that actually matter, and not to waste your time on something like registration and management tool. So definitely check out this VU app by our sponsors, FM Hub. And we will be joining our Q&A session in 15 minutes. So I guess let's take a quick break. Let's just stretch our backs, grab ourselves a coffee and maybe a sandwich, and we will be back in 10 minutes. Thank you, everyone. All right, we are back for our Q&A session, and I will add our speakers, Andrey and
Hi.
Hava.
Oh,
Hi.
Hi.
Hi again, and we will be waiting for Satyam, and yes, he joined us. Hi, Satyam.
Hi.
Welcome back, everyone. Welcome back, everyone, and we will start our Q&A session. And I want to ask our participants to be active in our chat and to actually contribute more of your questions, because we already have some, but I guess we still have some time left for even more questions. So please go ahead, add them to our special dedicated chat section for that. So let's start with the first one. And first of all, thank you for all your amazing presentation. It was terrific. It was very interesting and useful. And let's start our Q&A. So first question, and most of those questions will be general. And if one of the questions will be addressed to either one of you, I will basically specify who is it addressed for, and then everyone can take their turn after the person answers. So the first question is a general one, I believe. Working on monolith software, what would be the best step to take for developing it to a microservice architecture? So anyone can start. Just yeah, Satyam, let's start with you.
Sure. So let me pitch in. This looks very generic question. Like we need to be very specific. Like one could be when we talk about migrating the system. So what kind of approach we should take? The question could be on that side. Or second could be once I have some microservices. Let's say generally when we do a migration, I will try to pick a service which could be made independent. Let's say if I'm having my e-commerce application as a generic application, and if I want to take out my authentication, so I will try to pick very small service, and that I can take it out and probably I will try to have some patterns like we have seen when we want to do this kind of migration. It's always good to have smaller chunk and smaller functionality that to be tested before migrating each and everything. So I will always suggest to go for incremental approach. Try to pick the service which could be definitely make independent. Like in my case, let's say my authentication authorization,
Mhm.
and once that part is working well, and you are able to serve all your user, it's able to scale, then go for other kind of services on add-on. So one is on the deployment side also, right? So let's say if I'm having very specific service, then that need to be scaled separately. So totally depends how is your current application, and based
Okay.
on that we can suggest the possible approach.
Thank you. Hava, maybe you have something to add.
I really agree with the incremental approach, like do it step by step, service by service. And my take is like ask yourself, what is the problem that you are trying to solve? Like, why are you migrating from a monolithic software to a microservices? And based on the answer to this question, you might be able to choose what is the first service that you would extract out of the monolith into its own
Mhm.
microservice.
Okay. Andrey?
Okay. From my point of view, yeah, absolutely agree with Satyam and Hava. But what will be best step to take for developing to a microservice architecture? It's by far I understand about this question is so you are currently in a monolithic architecture, monolithic services, and then you would like to move to the microservice architecture, and then by that, the first approach that you need to be done is by implementing the modular monolith. It helps you to divide the context, the bounded context, which might help you to decide which service, which domain that you are going to separate first, and doing it incrementally is, as Satyam suggests, is a really good suggestion, and you may start from there. That's all I think I can answer from it.
Okay, thank you. Thank you. Let's start with another question. So the next question is, what is the difference in performance between monolithic and microservice applications? So what would be your take on this? So what is the difference? And we had similar question and it was a little bit broader. And actually, the question was placed something like this. What pros and what cons each system actually has, and why should one consider migrating to microservices, and why and when someone should take this step? So let's start backwards. Let's start with you, Andrey.
Okay, thank you, Paul. So, what is the difference between in performance? So, in performance, in here, if you are talking about the development speed, and then we might go with the microservices because microservices is divided your services, yeah, your services become a bonded context, which is like multiple services, and then you can deliver in parallel. So it's much faster for an agile company to adapt a new feature. But
Mhm.
if you are, but it's always a trade-off. There is why I always like to discuss about the cap theorem. So if you are implemented the synchronous monolithic, and then it's not a good one because it's always having a problem with the scalability or availability. So you need to overcome. You need to know about the pros and cons. So if you are
Mhm.
talking about the pros of the microservices, and then it's the it's independent deployability, speed up development, and then I forgot about the third one, and but it's focusing on that one. But if you're monolithic, if you are there is always a pros if you are working on the small team, and then you are I suggest that you are working on the monolithic because microservices is a lot of burden. It's a lot of responsibility that you need to take care of, and it's not a good one if you are coming from a small team. So
Okay.
it's all depends on your current situation. There is no silver bullet. That's
Okay.
that's.
Thank you. Hava?
Yeah, I agree that I guess in my experience, in many cases, the main reasons for moving from a monolithic to microservices is not necessarily performance, but rather dependencies and also development speed. It depends. Like there could be a fast monolith and a slow microservice. But I think that what needs to considered, what I recommend maybe is. It's a very good question to ask yourself when you start implementing a system. Like, it's much easier to start with microservices rather than break a monolith into multiple microservices. So that's another question to ask yourself when you consider the differences. You can also consider what's the price for switching or breaking a monolith into microservices. And also, like maybe one advantage of microservices is reusability among several products. There could be a piece of code that can be used in a larger organization. It could be used in several products, and then that's another gain by breaking a monolith into several microservices.
So basically, we can use them as some kind of blueprints for our own reusage and basically just keep them and the reusability of code. Okay, thank you. Satyam?
Okay, so if I'm going in different direction, like if the user is thinking like, let's say my monolith was giving me some specific performance, it could be either load time if I'm having web application, right? It could be either the response time of an API, right? So if you're thinking of performance in those terms, I will again say like it again depends how you are going to uh, choose the kind of pattern and principles. So let's take a simple case like if I have broke down my monolith into multiple services, and let's say initially my page load time was 10 seconds because I was just having a few API calls which are hitting to my one monolith system. Now, because I have 10 or 15 microservices, if I'm having multiple calls in between services, it could increase my load time, right? So
Yeah.
when we design the system, it's very, I will say, it's really important to think on something called we have dependency help, right? If you're building a microservice which is kind of very interdependent for a specific feature. So that's why it's really important when you design microservice, individual microservices should have their own bounded context, and it should be not based on just merely pages, or I will say based on a couple of use cases. It should be based on business capabilities, because when we build a monolith, generally your controllers part, if you're directly trying to convert to microservices, it's really a, I would say, a bad pattern, because if you're thinking your controller could be converted directly to microservices, then you are going to a place where each microservices will have interdependency.
Yep.
So if you're thinking about the performance improvement, I will suggest if you have good design in place when you have defined the microservices, definitely it will not degrade if it's not improving it. And because microservices rely on one more concept called async, and that is very common nowadays. Like people don't want to go for near real time. So I will again suggest the same thing. Like if you have very specific use case like where you want to go for real time, maybe we can think on something called sync. But generally, it's always to have async communication or async services, so that I should not have some other kind of dependency.
And another thing too that I would add from myself, sometimes when you're migrating from monoliths to microservices, you need to consider how it will actually impact such things like your NFRs, your non-functional requirements.
Correct.
Because those things that are actually sometimes we as developers, we don't really think about them that often, but the stakeholders, the product owners, they think about them. And sometimes you may be doing this to make your system more robust, to make it more load and stress resilient. But as Satyam mentioned, it may increase the latency. It may increase the time, the API calls, and everything like this. And basically, you're making something to improve the application, but on the user side, it looks like you basically downgraded your application. So that happened to one of the projects that we worked on. So yeah, that's actually one thing to keep in mind: the NFRs and what the stakeholders want. Okay, so let's continue with the next question. How to evaluate monolithic application to revamp into microservices? So how do you evaluate it? What do you start when you're doing this evaluation? So let's go from the middle and outward. Let's start with you, Hava.
Yeah, so basically you want to evaluate a monolith. So yeah, I guess from my experience, like what is evaluating? Evaluating is like looking into what you have in your monolith and then see like what actions or services belong together. It relates to service connectivity, like which service communicate with each other, so they make sense to be in the same microservice, and which services are not. It's basically related to my advice to like create a mapping of your existing features and existing functionality. And also set up the expectations, like what is the problem you are expecting to solve, and what are the metrics, what are the load that you should support. Yeah, basically those are my advices for the planning.
Basically, the why, what you want to achieve with this. Okay, thank you. Andrey, maybe you can add something.
Okay. Thank you, Paul. I'm strongly agree with what Hava already said about it. So I also think that you need to discuss it with your product team, because like Paul said before, it's about the non-functional requirement need to be considered. So for in our case, we have a multiple teams working parallel on a monolithic services, monolith architecture, and then it's like a bottleneck. So every time this team is releasing something, deploying something, and then it's always needs to be fixing impact from integrating the things that they already done, and it's also becoming the other teams missing the deadline. So it's always going that way, and it's hard to, even if you already implement the clean code and loosely coupled code, loosely coupled principle, solid principle, DI, and any other things, but it depends on the individual engineer. So it's always affecting. And so if you go on that way and then you lose the trust from your stakeholder, why even delivering this two feature is taking this long time, it doesn't need to be delivered in this long time. So you need to discuss it with them, because it's kind of communication problem, and it's kind of deployment problem, because your deployment is not really independent. So it's always going that way. So you need to thinking about that way. If everything is still under control, and then you need to discuss it with your stakeholder. Is it okay to go in that way? Or maybe if you have a manpower, have much time, enough time, educate people, and then you can discuss it with them, and you have, like maybe a little bit small feature going to be developed in the next sprint, and then you can go with it. It's okay to go with it, but there is a lot of things to be considered. So it's depends on the stakeholder, because business, especially for the startup, what you are going to release is really bringing a business value. It's really bringing impact to your business value, to your company business value. So it's what matters to them. It's not matter if you are implementing monolithic or microservices in our services. But what matters to the business people, to our company, is about what business value can be achieved on the next sprint. So you can negotiate with them because it's always needs to be balanced. That's from me. Thank you.
Thank you, Satyam.
Yeah, I think I completely agree with Hava and Ronald. Like, it should be around your business capability, and you should definitely check with your product and other teams. But if I'm thinking as a developer, and if I've given a system like this is a monolith, and if I have to evaluate like how I can convert to microservice, I can go with that approach like generally if I'm having MVC application, right? So I can go with my view layer first, and I can define like let's say in the view if I'm having some features and functionality, I will try to group them together to create a business capability. So that is the first step I'm going to do. Like I will see my code, I will have all my view layer, and I'm going to group them together, which I can think could be a business capability. And once that view layer is very clear to me, and I can see like these are the actually real feature which is going to be used, then I can see on my controller part, and then I can go dig down like if I'm having this is a business capability and these are my controller, how I can expose as an API, and then at last I will go for model layer, because then I can define like if I want to go for database per service, or I will have even maybe share database,
Sure.
and
Yeah.
then I am going to take a decision based on that.
That was very interesting what you just said, because the next question is going to be like this: when migrating from monolith to microservice, what about databases? How to avoid shared databases and to have consistent data in enterprise? So I guess Satyam, you can continue on this one if you
Sure.
can add something. So
Yeah.
please go ahead.
Definitely. So I think I have faced the same issue. I tried to go for microservices, and I used only one data source. And the problem we faced is if you don't think like your individual services should have their own data part, because we need to come out of that normalization, I will say mental state, because still if you talk with people, they are still thinking you have to normalize the data. But if you are going for microservice, I think that is the first thing is to discuss with that either your team, your architect. Like we are not going to think how to normalize the data, how to save data while storing it, because nowadays storage is very cheap. And I will say we need to change that mindset, because if you are still thinking on that normalization part, again you will have dependency on the data side, and you will have the shared databases. So my first suggestion is avoid as much as possible to have shared database. It's okay to duplicate the record. It's okay to have same data across multiple data sources, because that is how you're going to have your services independent. And then you can say it's really a microservice, because if you have shared database, just think it's not a microservice even for deployment. So I will say if you're thinking on microservice, have your separate database. Don't try to force feed your normalization and other principle, maybe which we have learned last 20 or 30 years. And now let's focus like data. We need to store each and everything. And that's why people are now going for event modeling, where you're going to store each and everything. Event sourcing is also there. So I will say have that mindset. It's okay to store all the data. It's okay to have everything, because nowadays if you see the real benefit or the places where we are going to find the product is on the analytics part, on the ML part. There again we need to revisit the data. So it's better to store each and everything, have independent data stored, and then we can decide what is the kind of use case we have.
And okay, if you want to add something, so Andrey, Hava, please.
Okay.
Yeah,
Thank you, Paul. I'm
yeah,
sorry.
sure. Go ahead.
Yeah. You may go first.
Okay,
I'm sorry.
I go.
Yeah.
I just wanted to say that that's a really good question. It's not a simple one. Like from one hand, ideally, each service should own its own database. But then things get complicated. For instance, in the user interface, you would like to display a table with data from multiple services. Then what would you do? Would you uh, um, gather data from two services and merge it together? That may be expensive. Maybe you would like to introduce a third database with data from both services that will be used only for UI serving. So I told you this use case in order just to say that it's not a simple question. It's really depend on how the data is being used by each and every service separately and by like the combination of services.
Okay.
Yeah,
Okay.
I'm sorry. Yeah, thank you, Hava. Thank you, Satyam. And I absolutely agree with Satyam and Hava. So this really a good question. I love this question because it's kind of what we're dealing with the microservices. It's for if you are a fan of Sam Newman, and then you must go with Hava because ideally it's supposed to be separated database, but it's hard to maintain, and it's okay for there is always a way, there is always a trade-off. So it's okay if you would like to go to the separated database, and then you can denormalize the database. So you may collect some necessary document and put it inside your separated database. So for example, service A may contain a necessary column from service B. So you don't need to call the service B every time you need anything, and you can just process it from your service A. But it's also having a problem with the consistency, because whenever you change, you update the data in the service B, and then the data in the service A, it's not updated. For example, we have an order service in here, order service, and then the product service. But we often got a query like collecting orders by a product name, so it can be searched by the product name. But we only store the ID in the product in the order service. We only store the product ID, and it's not good, because whenever every time you would like to collect the order with the product name, specific product name, or some sort of, and then you go to the product service, and in this product service, you may facing a problem with the payload size, because you may collect, for example, AS, and then you collect the whole data from this product service, and it's maybe like a 90K data, and then it's not a good one. We need to overcome that kind of problem, and there is a two way to overcome that kind of problem. The first way is you may to denormalize the thing, and then you distributed the necessary data and put it in the order data. So you may store the product name in along with the product ID in your order data. So whenever you would like to search on those specific product, you don't need to go to the product service. It's a good thing, but the problem is when you change the product name in here, you need to call the order service to update the data, and it's not a good thing because it's tightly coupled. It's not the way it's supposed to be working. And there's another solution like a API bulk service. API bulk service may overcome the problem because you may having another. We may discuss it later on. It takes too long. And if you are talking about the consistency, there is another two solution, which is the Saga pattern, and then the two-phase commit. Saga pattern comes up with two other design, which is the orchestrator and then the choreography. You may overcome the problem with the consistency on the microservices by implementing the Saga pattern or the two-phase commit. Maybe that's all I can answer for now. I'm sorry to take in for long.
Thank you very much. It was quite in depth. And we have a comment from Steffi Kiranrani. Satyam, great presentation on event modeling. Thank you. It is truly a game changer. And we have a question. So the question is, can event modeling be adopted for existing legacy systems or traditional state-based systems? So same question from the same person, from Steffi Kananani. So maybe start with you, Satyam. Maybe it's somehow connected to the talk that you gave.
Sure. So to answer the question, yes, it can be adapted for legacy system also, and your traditional state-based system. Yes, for that. And definitely it's been proven. Like I already give an example, like there are company like Capital One, they've already implemented their whole system using event modeling. And I will suggest like the places where you have event driven system, like it could be your e-commerce, it could be your financial. So there are places where we know like we have lots of events. It's always better to approach with event modeling. And in my like maybe it's my personal opinion. Nowadays, whatever application or system we are building, according to me, it's just information exchange. Like generally, we pass information from one place to another. Like if I'm not talking about building something like algorithm or very heavy data centric application, generally the kind of application we're dealing with, we pass the information. So whenever we have passing this kind of information across multiple modules, we rely on events, and in all these places, event modeling could be used.
Cool. Thank you. Hava?
It's a good question, but I guess I've never had a chance to model to use event modeling in existing systems.
Okay.
It's really.
Thank you. Fair enough. Fair enough. I agree. Maybe you can add something on this one.
Okay. Thank you, Paul. So even modeling, so the question is, can even modeling be adopted for existing legacy systems or traditional state-based system? Yeah, I agree with Satyam. I think he's more experienced in this instead of me. So yeah, I strongly agree with him. But I experienced once with it's like a retrial mechanism. So when we calling to the payment service, it's like an external service outside our payment service, and then we implement the event modeling event source. So it's we whenever the payment is created, and then we publish an event, and then this event can be consumed by the worker, and this worker can be do the retrial mechanism to call the payment service, the external payment service. And then yeah, it's absolutely can be done in the existing legacy system, but there is still chance need to be done. There is always have a chance to be on your legacy systems to be overcome.
Okay, thank you. And I guess the last question for this Q&A section, it just flew like that, whoop, and we're like 40 minutes, like it actually just started. Okay, the question is a general question. So migrating a monolith application to microservices, does it anyhow depend on the type and the size of application? So it's quite general, just let's toss in a couple sentences on this. Satyam.
Yeah, sure. Thanks. So definitely it depends because if you remember my presentation or our uh, uh, any one of our presenter, right? Generally, when we go for microservices, we need to evaluate our current system. Like it could be based on size, it could be based on capabilities. So I will again say like it depends on what is the size you're considering, because I won't say like if you're talking about, let's say, my build size or whatever RPM, if I'm deploying it or if I'm having container. If you're talking about that size, that is different. If you're talking about number of features, right, which you try to bundle together. So I will say for me the size here is how many capabilities you have. So let's say if you're having just 4 or 5 capabilities, and even you don't have any problem while scaling the system, or your team is able to work independently deploy, right? Even monolith is a good approach for that, because I won't say monolith is completely bad at all. Whenever we face a problem in monolith, then think to migrate to microservices. But if you're having small size monolith, which is very good, doing well in scaling part, your user is not having any issue, and if you want to add on top of any new feature, it's easier for you and you have lesser release cycle. I will still prefer to stay on the monolith. But if you're having all these kind of problems, and then I will say yes, it's better to switch for microservices. So your type and size, it completely depends how you are going to evaluate that part. And in my suggestion, if you're a small monolith, stay there only. No need to migrate to microservices.
Okay, thank you for that. Pretty substantial, and I guess we have 2 more questions, so let's just go through them because we just had a break. So let's cover the last 2 that we have. So the next question would be, what are most common microservice anti-patterns which people make when moved from monolith? Hava, maybe you can add something on this.
it's a good question about anti-patterns. I would say I would say that microservices, yes, it's about dependencies and about. I think dependencies that's an issue with microservices, and as long as you are making them independent of each other, that would be a good architecture. And if there are still dependencies, that would be.
Strong
Again,
anti-pattern,
facing
I
the
guess.
same problems of a monolith. So I would say anti-pattern is dependencies.
Okay, great. What about you?
Okay. So the microservice anti-pattern that common occurs is the n+1 query problem that so far that I know, because whenever you move to the microservice, and then you might face the problem with the n+1 query problems, and the other things is like the things that are already explained by Hava is the dependency. The dependency because it becomes the cascading failures. And the problem, the last one is about the BBO, the big ball of mud, because the monolith, after you separate them into specific services, or maybe you already clean them up, become microservices. And then the problem is there is a probability to specific services to become another distributed monolith, and then that's the problem. That's the point that we want to avoid. So yeah, we need to keep them cleaned for the specific responsibility for the services, for its services. Maybe that's all I can tell you about. Thank you.
Okay, and the last one, which platforms are available for applications and software development migration? So can you give us just maybe, let's say, one from each one of you? So if you would recommend some platforms.
Application. Okay, could you define platforms, because platforms for doing migrations is pretty much for in our experience it's not much, because it depends on our services, that the monolith services, monolithic service that we are going to migrate it. So the platform, if you are discussing about the platform available for application and software development migration, and you are discussing about the database, and right now we are using the PostgreSQL, and then it just runs well, but there's always a acid and base problem that you need to thinking before you are moving on, by before you're choosing the base, or maybe before you're choosing the NoSQL or the relational database. And by platform, if you're so I'm not really clear
I thought
about
maybe the person who asked the question, maybe they were implying that there are some solutions that help you to migrate, maybe some sort of automation, or maybe you have.
I must say that in each and every migration project that I performed, it was really dependent on the technology of the legacy system and the technology of the new system. There was no one platform I could have used, but for example, analytics, proper analytics. Okay, there is the legacy platform, and what analytics you can get from the legacy platform, and what analytics you can get from the new platform. Then testing. Okay, what technology are you writing the data conversion between one platform into the other? This technology will imply what is the testing capabilities you have and testing frameworks work. So I would say that I don't have a single platform that can help. I can have patterns or design patterns for online validation, offline validation, so on. The design patterns, and then how you implement them is highly dependent on the technologies you use in the new and the old system.
Thank you. And if you would think about something and you can add something, please drop a couple lines in the chat, because we stole 7 minutes of the break from our dear attendees. So I guess we're gonna wrap up. Thank you very much for actually joining us. Thank you very much for sharing your experience with us, and it was our pleasure. It was total bliss to have you all with us, and I guess we'll see you on our next summits, and thank you once again.
Yeah, thank you all. Thanks, Paul.
Thank you.
It was good coordination. Thanks. Bye.
Thanks. Bye.
Okay, and we will have. Whoa, Mike is here. How are you doing? Did I just somehow I put you into the stream?
You just wanted to talk to me, didn't you?
I want to talk to you, bro. How are you doing?
Oh man, I'm good. Just waking up, getting the stuff out of my eyes and everything, and got my protein drink and my coffee. Yeah,
Cool.
so I'm ready to go.
How's the jellyfish doing?
How the jellyfish? Well, hold on a second. And now you can see over here my fish, right?
Yeah.
Yeah, there's one of them there, and yeah, they're doing good. Jellyfish are doing good. They're a lot of work. I'll just put it that way. You know, when you get something, you get excited, right? And then after a while, you're like, it's like a new car, right?
Yeah.
You know, you get this beautiful car, and then all of a sudden you wash it and go, "What's that? A scratch?" So it's like, oh no, it's a little work.
What's that? Did it just die?
Yeah, dude, I don't. Oh my gosh, one of them looks like it went through a filter. It looks pretty bad. But the jellyfish is kind of hanging there like, oh man, I gave too much info.
Okay, and I guess everyone looks like no break, everyone, because we just had a break before the Q&A session. So we're just gonna roll into the next session, and we'll just pause for a quick announcement from our beautiful community manager, and we will be back in 2 minutes or something like that. And I will be transferring floor to you, and we will be waiting for Ivan, the amazing Ivan Costa, who will be joining us in just a couple of minutes. So. It was Paul. Thank you for having me as your host, and we'll see you later today.
See you later, bro. Great job.
See you later.
Yeah.
If you are interested in the world of blockchain technology, you would definitely want to check out our Blockchain Tech Summit 21. Interested top experts will join us to talk about the future of the domain and share real-life examples for this amazing technology. If you are interested in switching to blockchain development, don't miss your chance to get our tickets at 50% discount. To get the deal, just use our special promo code SUMMER50 at checkout.
Hey, I was just here. So how's everyone going? Oh, but word, I've got the last block of this track of this time with you, and we're gonna have a great time. We really are. I can't wait. I was already talking to my buddy over there, Paul. You know, I got my fish going on and jellyfish, and oh yeah. So I'm from Pandey, California, and the sun's just coming up, and I've had all my protein drinks, and I'm ready to go. So I'm going to bring in my next guest here. I think is Ivan. Hey, Ivan, what's up?
Hi,
bro.
Hi, Michael. How are you doing? Hi, everyone.
I'm doing good. I'm doing good. How about you? How's it going? Where are you? Where are you right now?
At this moment, I'm in Brazil, but I live in Chile. I'm in South America, but I'm here in Brazil by a few weeks and coming back to Chile next week.
Oh, crazy.
I live in Chile and at this moment in Brazil. I'm Brazilian and stay here a few days to visit my family. Because of the coronavirus, I have been almost 2 years without seeing my mother, my family, and here to visit him.
Oh, that's awesome, man. So you kind of like me, you kind of can telework, right? And move where you need to go to do your work. COVID's been good that way. I'm serious, because I don't I know. I will have to go into work and drive and traffic and, stoplights and I can just do all my work from, and then I love Starbucks. Oop, that wasn't an advertising, but I do. I love going and coding and stuff like that. What do you got for us today? So what are you going to talk about?
I have some tips about cybersecurity, because we have a lot of, especially because in the last days, last months and last year, we have a lot of kind of attacks, hacking attacks, ransomware, and a lot of things, and need to improve our security. And I'm here today to talk a little bit more about SAP security. how we could secure our systems, what we could do to make our systems secure enough to maintain the company running without disruption. And I have some tips. What we did here where I work for Coca-Cola Andina. It's a bottler from Coca-Cola in South America. And we made it to our systems. We think about we are safe. No, we are not safe. We start to make a lot of things and start to discover a lot of points, a lot of problems in our systems. Then, okay, what we could do and what we could share with the community to show, to give tips, what the people could do to make your system safe. Of course, nothing's 100% safe, but
Right.
we could make something to make him safer than
Wow. Wow, bro, I'm so excited. I'm going to pull your slides in here.
Good.
And I got nothing to say. I'm going to get off stage here, and I'm just going to let you take it from here. Have a good one, man. Have a great presentation.
Thanks, Michael. Hello, everyone. Let's start with some kind of formation, a little bit of information, because security is very, there is a lot of information. But let's talk a little bit about what you could do to make your SAP and your system safer than now. My name is Ivan Costa. I'm an IT technical architect working at Coca-Cola Andina and working with SAP since 2006. I have been working a lot of projects for Andina. And what is Andina? Andina is a Coca-Cola bottler in South America. We are in Argentina, Brazil, Chile, and Paraguay. Okay. Now let's go to what is interesting. We talk today about SOS report. It's a report where you could identify some pain points, weakness on your system. SAP hot notes, what the SAP give to you to repair some points which they discovered using the clients or his labs to identify the problems, how you could create a contingency for your SAP system, and one specific point, not only for SAP, about immutable backups. It's about what we have nowadays with ransomwares and everything who could kidnap our information, okay? Okay, let's start. SAP have tools to help us to make the system safer. One of these tools is SOS report or security optimization service. These have no cost. Every client of SAP could start this report and start to make these repairs, these change to make your SAP safer. There's no cost. Of course, you need to activate. We'll look a little bit about what this report deliver to you and how you could execute in your system. Of course, we like only few screens, but we'll show to you an example of this report to you to know what SAP could bring you to make this safer. Of course, this is not 100% to your system. There is some points you need to have your functional team to identify and show you what you could show to everyone or know what kind of information you need to hide and something like it. Okay, there is a sub note about this process. It's here. After the presentation, you could look and research on internet on SAP page about this note, the 1484, and get more information. What the report analyze? All the technical configuration. If you have, for example, some ports, some configurations, some points which SAP bring you open, but depending on your need, you must close, not maintain open these connections. Some kind of users where you should change because they are system users, admin users. Provide you recommendations to solve these problems in the final overview with all your pain points and with levels. Is priorities, not priority. Okay, it's nice to have, but these are the 3 points: analysis, recommendation, and summarize information at the end. Okay, as I said before, segregation of duties, security organization, administration process are not in this report. These points you need to check with your team, internal team, functional team. Okay. In our case, what we found, we think, okay, we are safe, we are secure, we have no problems. But when we start the process, we save this red sign. You have a severe critical security problems. Okay, there are 87 pages of recommendations. Like, not all sub-clients have these audit logs, and more than 15,000 users with some kind of problems, like could access some information which SAP recommends to not have this information open, and other pain points, like some user with several users to maintain all tables and other points. I will show you some points about our report, and after it, I will show you a complete report with more information. This complete report is not from us, is an example from SAP, but it's very good to identify some similarities with your systems. Okay. First, we identified a lot of points, like a big report. And SAP shows a lot of issues detected, like super users, a lot of users where users could change the password from other users. But here comes an information. In this case, we could have these users because we have a very big help desk, and this help desk could change these passwords. Then at this point, it's okay, because if it is a recommendation, it's not the true for your company. Then you need to analyze and check, okay, it could be applied for us. Okay, perfect. Let's apply this to our system. Or, okay, it's okay. We'll maintain this. It's still appearing in the report, but it's okay. We have a lot of basic recommendation, like RFC gateways. You should block some connections. It's good because not day-to-day operations, something like you configure it once and only change few moments during your life in the system. And some kind of profile standard users, this is a very good point, because a lot of companies doesn't have these users under control. Then sometimes you could have an evasion, a hacking attack using the standard users. Then is a very interesting information. This is a little bit about what we have and how we could generate this report. It's easy, it's not complicated. You need to check some pre-hacks before you start to implement. But if you have all pre-hacks, okay, like version, you should be in an updated version, not so old, like you have a social manager from 5 years old. With a 5-year-old, maybe you could have any kind of problem. But if your system is up to date, it's okay. So there is no problem. You need to have the social manager. It's free for all sub customers. Then in social manager, you have a transaction as a work center, and you have to navigate a sub engagement and service delivery group here in my sessions. Here you could create this service, the sub security organization service. And here is like next. You need to choose your system, which system you want to run the report to identify the problems. You could run for each system one by one, identifying all your problems and solving making repairs. Okay, next. Basically, you assign a scope depending on your system, and the standard page from SAP. At the end, you will save this information, the service report, where you have a PDF or Word document with all recommendations from SAP. Of course, here we're not running live the report because it took a lot of hours to have been created. It checks all the connection, checks all the users, the profile, the roles about the users. But we have here an example from SAP. Let me share with you. This is the report from SAP. Of course, it's an example. There's a lot of pages because it's a full report with all considerations. Here we have specific focus checks, especially about the users and recommendation from roles. I have some points, very interesting points to show you. For example, here we have a lot of users with SAP all authorization. For the people who is working some time with SAP, they will know SAP is like you are a god, is a pseudo in SAP. Then sometimes somebody could have this role, but it's not recommended. You need to take off all SAP from your system. Then this report shows you how many users I have here with SAP. This is the first recommendation. Of course, maybe you do not have any user with this situation, but if you have, you should to change immediately. And here, another point, the size of password, the length, and etc. And as I said, SAP give you a recommendation. What you should do. Recommendation, assign value, minimum value, initial password, and shows you the kind of risk. In this case, it's high. Then you should to move and change this. Some risks are medium or low. Okay, you need to try to get this risk high before, and of course, make your roadmap to change it, and get more security for your system. Let's show you more interesting information from this report. Put logon. This is a very interesting point here, because in this case, it's not only about security. Of course, if a user is connected to your system, it's interesting to not have another user log into the system using the same password. But besides this, you have a license problem here. If you are using SAP and have a lot of users logging in your system at the same time, it could show, besides the security problem, a license, because SAP could audit your system and says, okay, you have, for example, one user being used by 10 users. Then it apply you a penalty about this additional users. Everything is logged on the system, and system has this information. Then besides the security, you need to have attention in this point, because you could have a cost on your system, on your license, and it could be a very big problem. Here we still have points about the system. In this case, about profile system. SAP could have a lot of servers, and each server has his profile file in your startup. Then sometimes you have a profile in a server, in a different profile in another server. In this case, you could have a security problem and a configuration problem. You could access the system, have very good functionalities here, and when you come back and log on again, you have another situation where something could not happen and working better. In this case, the report shows you, okay, you do not have all the profiles configuration at the same configuration. Recommendation should import all the files in each server. It's a very good point, besides the security points. Let's go to another kind of problem very common in SAP installations. We have human resources information. This kind of information is very, very complicated because everything about the payment. Imagine if the salary of managers, directors, and everybody on the company open to everyone could look this information. It would be a very big problem, a huge problem. Then this report shows, okay, you have some users or a lot of users who could access this kind of information. You have a full information about it. There's a lot of points about what you should do to avoid this kind of leak, information leak. In this case, all the risks usually are high because this is very sensible information. We have information about connections. In our database, we have a lot of technical recommendations. In this case, we are looking for a SAP over a HANA database. And here we have points like TLS configuration. It's not encrypted. This is a very good recommendation to encrypt your data. And go ahead with other interesting points. In this case, when we have a HANA system, we have a system user who runs all the communication between the application and the database. In some cases, somebody could be using this user because he's a very powerful user. Then in this case, the report shows you, look, somebody is using this, logging with this user. You shouldn't use this user to anything. Maybe during the installation, it's okay. But after it, you need to use your own user and personal user to make any kind of maintenance or change on the system. And in the report will show you this kind of information before you have any other problem. You have a lot of kind of problematic users. Usually it could be obsolete, or of course you need to take off these users from the system to not maintain. Because if you have a lot of users who never log in the system, these are possible point of invasion because a hacker could get a user with your initial password and will hack and enter it. Then you should check all the users which never been used and took an action, or erase these users, delete these users, or create some kind of policy to maintain what you should do, expire the passwords. You need to take any kind of action. And at the end, we have the conclusion, where SAP shows us a report with some information about different types of user, dialogue, communications, the methodology about the risks, why SAP says, okay, it's right, high, it's medium, it's low, and the rating of each recommendation. Of course, you need to attack the most criticals to start to have a better system. Of course, it's not easy to implement. Maybe it could take months to implement because some change could stop some kind of application. You should apply this first on your dev and QA systems, maintain by a while, ask to the team to make a lot of tests, try to test the most critical process, and after it, put on the productive system. Okay, this is the example I have here. Let me get back to the presentation. Okay, another point, it's about the SAP hot notes and security notes. What's this? Like a Windows update. You have some patches from Windows, and SAP had this kind of patch. Of course, when you have a Windows computer, you should apply every patch with Microsoft delivers to you. But in SAP case, it's depending of the different solutions you have. If you have only the ECC, the ERP, maybe you have a few nodes. But if you have a lot of sub-solutions, you have a lot of different nodes. In our case, I bring here an example. We revised 228 nodes because we are comparing what kind of solution the nodes here are pointed and directed and what kind of solution we have. And we have 111 we could implement because sometimes you need to check, okay, this applied to this version or applied only to older versions or new versions. You need to look the nodes and okay, it's applied to, for example, SAP 607, for example. Okay, I have 607. Okay, perfect. I could apply this node. This is a very good point to identify all the problems and even problems not identified by your organization, because SAP get all the tickets from all the world, get this information and have his own labs and start to look, okay, we identified a security problem or a fail in our codes. Then they deliver this note for all clients or customer of SAP. In our case, what we do here, we apply development and QA system, maintain during a month to identify any strange situation like, okay, I put it on QA and the user start to complain about, okay, now I have problems to connect using a handheld, for example, or using my cell phone. Okay, it could be caused by this node. Then we come back and take a look. But if you do not have any problem, say a month working in QA system, we apply in the productive system. Of course, thinking about do not apply together another huge change on our productive system to avoid this kind of doubt. Okay, it's a problem from the nodes or it's caused by another thing. Okay, it's easy to get these nodes. There's two ways. One way is to enter on the SAP Marketplace, and we have two specific points where you could look this hot news. These notes are not only about security, it could be about an error. Then it's important to apply these notes every time you can. And security notes. This is only about security. There is a lot of recommendations you should apply immediately because it's a big problem, or you could wait. And when you enter here, you could look the notes here. I will open to you because it's very, very small here. Give me a second to show you online. Here we have the SAP hot news and security notes here. When we enter here, we could look what SAP gives us the last days, or if something is here because we are awaiting some action. And here we start to identify, for example, some case where it not apply for us. For example, in this case, I do not have Oracle database. In this case, this SAP note doesn't apply for us because we do not have Oracle. Then in this case, we could take off this note here from here and maintain the list until we have applied all the notes. The security notes are the same. The security notes, we enter here and have a list of nodes which we should apply with his score. Some kind have a big score, like it's about a program error, and it's a hot news too. Like I said before, it is a security problem, it's a hot news, but it is a program error. And here you could enter and read the nodes, identify if this node applies to your system. This node is the version 8. Maybe we already applied this node for our system, but we need to check. And have been updated 13 July. Then if you do this monthly, you will have a very, very safer system. Let me show you another way to have this information. You can have this information, send a mail to SAP and asking to include you on a list, to subscribe to this list, and start to receive monthly the list of nodes. It is very interesting because you have the same information but in an Excel document, and you could look, you put your information, take off what you do not need, and etc. Okay, let's go to the conscience on-premise and cloud. I talk a lot about security on SAP, but if you have any kind of problem on your system, like if your hardware fails, it's another point which you start to think about what we could do to make our system safer than now. Then we already have a lot of conscious disaster cover sites, but we start to implement new functionalities. In this case, we start to use functionality from Dell EMC. About this functionality is about move our data from a site to another site through a storage and through a fiber channel. And what we have in this solution, a recovery point where you could get back in time until 1 hour. It's like a time machine. If you identify any kind of problem in our system, like now, I identified I had a problem 5 minutes before. I could stop everything and using pointers come back in time 5 minutes before and come back the company working without problems. This is a combination of two solutions. One is about data cover where you have another site. Let me show you. This is better to explain. I have a production site and a remote site where I replicate all the information from our SAP from the productive site to a remote site. Then, in this case, if I have any kind of disaster, fire, any kind of problem on the production site, I could start to work almost immediately on the remote site. In this case, I'm okay to natural disasters, some kind of power surge, any kind of problem on the site, on the data center. But if I have any kind of human problem, like somebody made a change on the database and corrupt a lot of tables, a lot of data, or the whole database. In this case, as we have a replica through the fiber channel from a storage to another storage, all this kind of problem will be replicated to this other site. Then it's not sufficient. We will lose everything, even having a disaster cover site. In this case, we need to have a recovery point solution like we have here. We have a journal, it's generating all the change in points, in specific points like 1 minute, and putting everything on a special storage where, in this case, if it happens something like it and broke the system with some kind of interference, some kind of go live projects, everything, if something happens, I could back in time until 1 hour, but it could be configured to have more time and reconstruct my system at this point. This is what we're looking for our safety where this is already implemented for us, but it's a good point to have in mind to your company to have this solution come back. There is a lot of different solutions on the market. We are using the solution from VMware and Dell EMC, but there is a lot of different solutions on the market. You could choose what is better for you, what is fixed better in their pockets and the price, and it's at your budget. And besides that, you could made it to the cloud. Then in this case, you could have your data center and another data center in the cloud. Of course, you need to plan depending on the size of your system. Huge systems is difficult to make it, but you could make it to another site, another place, another country. Even putting a third contingency, as like we are trying to do. We have two, and we want a third contingency to, if in case of I have a problem in data center 1, data center 2, okay, I have a third data center. Okay, it's a very good point to think. And the last one is about immutable backup. Here we start to think about it. There is a lot of different solutions on the market. Like the solution of application, you should look what is good for a budget. And in this case, what is the immutable backup? Immutable backup is simply a backup where nobody could change this information. In a immutable backup, if you have, for example, a ransomware or something happened on your system, on your network, you could lose your data by a ransomware, a human error. Maybe somebody is trying to clean up free space and erase your backup. And if you need, okay, backup is erased. Simply deletion, or some kind of problem. If you have a problem, maybe you could lose your backup. But when you have a immutable backup, of course, nothing is 100% guaranteed. But you will avoid human error, ransomware, deletion, because this immutable backup, depending of the configuration, you will create this backup and you maintain lifetime. Or you could put 6 months, for example, and only after 6 months he start to be mutable. Here, of course, you avoid some bugs in the system. Okay, you could say, Ivan, but I have the backup in tapes. Okay, you could have your backup in tapes, but nowadays a lot of companies does make all the backups straight to the tape. You made a disk backup by the performance, and after it you move this backup to the tape. And if during this time, some companies work with backup tapes after 24 hours. If during this time you have any kind of problem, any kind of invasion, or being attacked by a ransomware, you could lose everything. Then this is a good solution to maintain your data. In case you are being hacked or attacked by a ransomware, you could get your backup back, restore your system, and get back in track working to the company. Okay. Here I put some reference about sub nodes, the SOS, and recovery point. There is a lot of information here, white papers about these things. You could look, see if it's fixed for you, if it's good, it fits for your company budget. And thank you very much. This is all I have for today. And we'll see you again in QA session in a few minutes, I think.
Yeah. Oh, Ivan, man, whoa. So I wrote down some questions myself, and I got them, and we'll bring them up in QA. I think we got a few minutes, but
yeah, I think you have 2 minutes. Yes.
Yeah, I appreciate it. You know, we got a little time here because as you're going through it, I'm like, wait, is this like because I had to go through this like a vulnerabilities kind of scan for one of the applications I was writing. I hate those.
Yes, I didn't enter on the application, but this is a good point with this report. Shows you some points. Look, here you have a code where you have a problem here, maybe a security problem. It's very interesting because you could have a door open to the hackers. We don't like this kind of thing, but it could happen.
Yeah.
It should be secure.
But the problem with the report, it would generate like 100 different problems.
Yes, but it's example. It's example. I hope if somebody run this report, there's few pages for us, a lot of pages because we run this first time. It's like a surprise. It's like, whoa, I just realized I have this problem. Because you try to apply some standard configurations, but you do not think in all systems. Only if you have a CISO where you have somebody looking straight to the security. But we know, like the memes on the internet, we have a lot of the budget with the CISO once is like this. The budget from the company is like this. Then last year we saw the increase of all the budgets for security on the companies, but in the past 2 years ago, usually the budget's like it for the security points because it's not show anything. It's not like, okay, I will buy an application and this application will give me more 10% of profit. Okay, no, security, you put the money and you never saw this use. You do not have a payback for security. Your payback is stay running. But sometimes for the company, only stay running is not show anything. Not sufficient to prove to the company. Sometimes the people from the financial team don't put money in it because, okay, it's not a problem. We have backup. We have backup. If we lost everything, we made a historian. Okay, but it's not. It's not like it.
Right. Yeah, and I agree with you because we come up with these really crazy, because this whole enterprise architecture summit, right? And we come up with these really super cool, awesome, technology designs. I know, like you, we forget the security aspect of it. And then when we do, then I got a story actually. So when I was implementing this one, it was a web portal architecture, right? The CISO, the security officer, turns to me and goes, "Where's your security plan?" Oh my word! I was like, I have no idea. I'm just a developer. That's my excuse. She got so mad at me. Wait, nobody tell that story back to my work, but it's true. And the thing is we forgot where to put this into what security plan and what contingencies. And I saw your backup part because it's very important, isn't it? Right?
Yes, exactly. Like I said, usually the developers think about, I need to make this to run fine, to run flat without problem. Okay, but at the end, it's not the responsibility of the developer thinking it during this plan. Of course, it's somebody will ask about what is your continuity process and plan procedure. Okay, we are here just to identify these points, and this report is very good to show us these pain points, which you forgot during our day-to-day. We forgot a lot of things. We are thinking about what I need to do I need to buy the hosting. We need to put the team to work. I need to plan the project. I need to run my daily meetings, and that's a lot of things, and we could forget. And even especially when you have a system already running, like if you have an SAP running, you got to think about a lot of other things. Like I need to make an upgrade, apply some notes because some developer asked me to do this. I have a new project, need to think about the performance, but a lot of times you do not think about security.
Yes.
Then when you run this report, appears a lot of it's like scary. It's like I have this lot of problems. Yes, but you could fix it and have a good night of sleep, not thinking about being hacked by somebody.
Right. Ivan, I gotta let you go. We could talk for hours, but we'll come back in the Q&A because definitely got more. I got more questions, and I'm sure those questions are going to come in on it. Thank you for your time. Wonderful presentation.
Thank you to you.
And I'll see you in a bit.
Okay.
Bye-bye.
Thanks, Michael. Bye-bye.
Bye-bye. Okay, everybody. Wow. It just gets good and better, doesn't it? I'm going to bring in my next guest. It's Andrey here. Hey, Andrey, how's it going?
Hey, good. Thanks. How are you?
all fired up. The sun's coming up in the morning over here in California. Where are you? Where are you located?
Yeah, I'm in London, actually. It's not that sunny as in California, maybe, but yeah, that's good.
Well, if you ever want the sun, just come hang out with me or something. We got tons of sun. We don't ever have any clouds or any rain. So anyway, it's another story. What do you got for us today? What are you going to talk about?
Today we will talk about the cloud networking, right, and how different cloud providers, like specifically we will look on AWS and GCP, Google Cloud, how they approach networking, like, and what's similar and what's different in their products.
That sounds so amazing. I can't wait. So what I'm going to do is I'm going to bring in your slides here, and I'm going to leave, and have a great time, man. Good luck.
Cool. Thanks. Okay. So, yes. Hello, everyone. And first of all, thank you all who joined us. And yeah, as I just mentioned, we will talk about cloud networking, because cloud networking is one of the base services of the cloud, right? And without a network, there probably will be no cloud, right? And in this talk, we will see how different cloud providers, specifically AWS and Google Cloud, how they approach cloud networking, which concepts are similar, and what's done differently. So yeah, but first, please let me briefly introduce myself. My name is Andrey. I am solutions architect at Digital, based in London. And during the past years, I worked for different companies, different projects, different sizes, from small startups to huge enterprises. And as you all probably know, the latest trend in software development is go with cloud, right? So whether it's migration to the cloud, or maybe you starting something new from scratch in the cloud, but usually it's all about the cloud. And this is why cloud is so important for modern computing. And as networking is one of the base cloud services, it's important to understand how it's organized and which concepts are used by different cloud providers. So actually, every cloud provider sees cloud networking in its own way. And this affects their features or high-level concepts. So while historically all these concepts came from traditional networking, from like the pre-cloud era, the details of their current realization may vary. And it's really important to understand the differences between cloud providers, because if you have experience working with some cloud, with some particular cloud, you often tend to assume that all other providers implemented everything in the same way, and maybe just named or branded it differently, which is not true, and could lead to some misconceptions. And of course, not everything is different, and there are many, many similarities. But as we will see, not everything is completely similar. So every cloud provider delivers a wide range of products and services. But as it's impossible to cover everything, here today we'll look only on what's related to networking and how the network is organized from geographical perspective. So what's underneath? We'll look on scope of services and VPC peering, and of course load balancing. But it will be more like high-level overview and comparison of two cloud providers, as I already mentioned, AWS and GCP. Both of them are really well known. And regarding AWS, I think it's fair to say that AWS is a pioneer in cloud computing, and that means that they often tend to stick to more traditional concepts, if we can put it that way. And maybe just because it's easy to go with something that you already know, right? Or maybe there were some other reasons for this, who knows? And just before we'll start, just remember that both AWS and GCP are evolving very fast, and it's always possible that something new was released or changed recently or will be changed very soon. So it's always worth double-checking directly in the console, because sometimes even official documentation could be outdated. Also, please let me stress that I'm not an AWS or GCP employee and not affiliated with them, and everything that we'll discuss today can be found in public sources. So let's get started. When talking about such basically a physical thing as a computer network, it's absolutely necessary to cover geographical presence. So let's start with this. And yeah, I know that a lot of talks about cloud computing beginning with geographical presence, but on the other hand, we have to mention it, right? So please let me be quick here. So resources and services of both cloud providers are hosted in multiple locations around the globe, and both GCP and AWS use the same term, region, for these locations, which is pretty intuitive because region is nothing more than a geographical region, such as US West 1 or Asia East 2 and so on. And just a few words on why this is important. So choosing the right location for your project may be very important because it will affect network performance, such as latency, for example. And usually you want your network to be as fast as possible, which means not only enough bandwidth, but also small latency. But latency will be different for each end user. And the general rule is the closer user is to your service, the smaller latency will be. So geographical presence is very important because if you place all your workload in one region, but the majority of your users will be in another region, they will probably experience latency far from optimal, and it could affect user experience. So if we look on the map, then both AWS and GCP presence looks about the same, at least from the high-level perspective. So this is map for the GCP, and here is AWS. So one more time, I go back to GCP and AWS again, and as you can see, it's like on the high level, it looks like more or less the same. So difference, might be down up to a certain location. Like for example, here in AWS we have presence in Sweden, but for GCP we have neighboring Finland. Or look on the United States, for example. So for AWS, we have this East Coast, West Coast, and for GCP, distribution is a little bit different. But bear in mind that these maps show only regions where data centers offering base services are located. And the actual network of edge locations and CDN network is bigger and larger for both providers. So every time when you start a new project, it's worth thinking about where users and corresponding systems will be located. But what's under the hood of their networks? Well, actually for AWS, we don't have much information how the network is organized internally, or at least I can't find anything in open sources. But Google sometimes reveals its network internals and in their blog posts or presentations. And of course, all of these are intended to play an important role in marketing campaigns, but still we can get some useful information from it. And from there, we can learn about their high-speed network and Andromeda virtual stack. But keep in mind, that it's all hidden from the end user perspective and is only made known for us, maybe more from a marketing standpoint. So while we are using it, we can't really control it or look under the hood of a networking product and see Andromeda of with our eyes, or touch Jupiter with our hands. So it's here more from just a curiosity perspective, maybe. So Google's opinion is that running a fast, efficient, hyperscale network for internal data centers is not sufficient for a good user experience. And that's why Google has created Andromeda. Andromeda is a software-defined network, or SDN for short, acting as an orchestration point for provisioning, configuring, and managing virtual networks in networking, and also in network packet processing. So I will not deep dive into Andromeda unique features and architecture right now, because it's probably something to be done by a Google employee. But if you wish to find out more, just Google it. But generally speaking, Andromeda's unique features are set to be best suited for a network of virtual computers. Or, if we will rephrase it, for computer clouds, right? Because after all, we can think of a computer cloud as just a network of virtual computers. Andromeda's goal is to expose the raw performance of the underlying network. And also Google exposes the same in-network processing that enables their internal services to scale, while remaining extensible and isolated for end users. And this functionality includes features like DDoS protection, transparent service load balancing, access control lists, and so on. So one more time, Andromeda itself is not Google Cloud Platform networking product. Rather, it's like the basis for delivering GCP networking services with high performance, availability, isolation, security, and so on. So, for example, GCP firewalls, routing, and forwarding rules all use underlying internal Andromeda API and infrastructure. And having said that much about Google, I have to turn back to AWS and stress the fact that AWS internal network is not necessarily worse than Andromeda. We just don't know. And because AWS is not that open about the underlying network technologies. So maybe it's a sign that they have nothing good to be proud of, or maybe it's just a part of their marketing strategy, which is focused more on a product rather than implementation. Who knows? In any case, there's not much information about AWS internals, but I personally feel like they have something more traditional, if we can put it this way. So for both cloud providers, every region consists of zones, and while naming is similar for both providers, hidden low-level organization of things seems to be different. So in Google Cloud, it's called just zone, while in AWS it's called availability zone, or AZ for short. So zones are named as the region they're in, plus one additional letter to distinguish one zone from another, like US West 1A or West 1B, and so on and so on. So in both GCP and AWS, mapping of zone names to actual physical zones is done on a per client basis. And this means that what's called zone, for example, US West 1A for me, may be called West 1B for you. So like the same physical zone will be named differently for different clients, different accounts. And if you struggle to understand what is availability zone, then, well, at least for AWS, as you can see here, zone is one or more discrete data centers. And probably it will all make more sense now, right? So availability zone is just a data center. And for everyone who's used to pre-cloud traditional computing, this might be easy to bear in mind. But for Google Cloud, it's different. Zone is hosted on one or more clusters, as you can read here. So from this statement, it's potentially possible for Google Cloud to have 2 or more zones in the same data center, just different physical clusters. For example, Google Cloud Region Europe North 1 is named Finland. But there's only one Google data center in Finland near the town of Hamina, and that leaves us no choice but to assume that all zones of Europe North 1 are physically located there. So for both providers, usually at least 3 zones will form a region. There are exceptions, of course, but usually it's 3 zones per region. Zones within a region are interconnected using redundant links, which is how high availability is achieved. If one zone fails, the region as a whole will survive. And one thing that's unique to Google Cloud and is absent in AWS is network service tiers. There are 2 tiers, standard tier and premium tier. And standard tier, which is cheaper, provides performance compatible to other public clouds. So this is a quote from Google documentation, like performance compatible to other public clouds, as Google say. And choosing the standard tier connects you to Google lower performance network, but which is still highly competitive with other public cloud services. Your load balancing services remain regional. And this option is maybe better for cases where cost outweighs performance consideration. But standard tier is available only at certain locations. On the other hand, premium tier, to which you are connected by default, by the way, is faster, and better performance is achieved by routing traffic through Google's private fiber network as much as possible. So your traffic is prioritized and routed through the fewest hops via the fastest path to accelerate transport speeds. And you also gain access to global network load balancers. So as you can see, for standard tier, traffic from the end user to your cloud will go over the public internet via the traffic exchanges, like several traffic exchanges of several different providers. While with premium tier, traffic from the user to the cloud, or maybe in the opposite direction, from the cloud to the end user, will travel through the Google's private fiber network as much as possible. But why there are 2 tiers, and why are they not available in every location? Well, actually, why the standard tier is not available in every location? Well, I can only imagine that this could be a trace of Andromeda here, but we can't know for sure, and that's definitely speculation. Okay, so maybe enough about such physical stuff as network speed and geographical presence. Now let's talk a little bit about how your cloud resources can be organized logically. And first, we need to mention the service scope. Some services and products are global, exist in global scope, while other are constrained by region or even a zone. And most of AWS managed services are regional, except things like CloudFront or Route 53 and so on. On the other hand, GCP treats networking as a global feature that spans, excuse me, that spans all services. And software-defined networking allows Google Cloud services to implement networking features that fit the service's exact needs, such as firewalls for virtual machines and compute engine, or fast connections between database and database nodes and other products. And most of the networking entities in Google Cloud, such as load balancers, firewall rules, routing tables, they have global scope. More importantly, networks themselves have global scope. And this means that you can have a single private IP space that's global without having to connect multiple private networks and manage those spaces separately. And this is a significant difference with AWS, where there are more regional products. And one of the things that's regional in AWS but is global in GCP is Virtual Private Cloud, or VPC for short. So basically, Virtual Private Cloud is isolated part of the cloud where you can logically organize all cloud resources that are bound to a specific project or any other grouping you want. From a technical perspective, VPC can be understood as a network, but network itself is not a VPC. So Virtual Private Cloud is like a private pool of resources within a public cloud. And on a high level, VPCs are similar to AWS and GCP. But when you look more closely, then you can find some interesting differences. Like Google Cloud VPCs are global, with subnets inside VPC being zonal resources, while in AWS, VPCs are regional. And in fact, when you create a new VPC in GCP, subnets in all available regions will be created for you automatically. But you can switch to the manual mode and define subnets only for the regions you need. So while VPC in Google Cloud is global by default, you always can switch to a manual mode and just switch off the regions and subnets you don't need. But VPCs and scope of services, it's more about technical accessibility and grouping. And another important question is how resources and access to them are grouped and managed on the organizational level, or how resources are organized inside the cloud platform account. And actually, this is not really related to networking, but this is an important topic and related to resource management. And anyway, we need this to understand the difference in VPC peering, which will be the next topic. So in any case, resource hierarchies, sometimes if you work only with smaller projects, so this topic may look like is not very important. But for larger organizations with multiple units and departments owning different projects, this topic is very important, because bad hierarchy design might lead to security issues and compromise production workloads. So let's see and let's compare our clouds in this area. So both clouds have 4 levels of organization, where top 2 are optional. Levels of AWS are organization, organizational unit, accounts, and resources themselves. So using of AWS services requires having an AWS account, since all services are created, enabled, or used within an account. But using of organization or organizational units are optional. So basically, organization entity represents an organization and just used to manage multiple accounts as a single unit. Organizations with multiple accounts can use this organization entity to maybe centrally view and manage all of their accounts in the same place. And it's like a parent container for everything else. So organizational unit is a container for accounts within organization. However, organizational units cannot be used without the organization entity. So if you want to group your accounts into organizational units, you have to create organization first. Organizational units can contain accounts, other organizational units, or a combination of both. And in practice, this is usually how we will model the organizational project structure within the organization. So, for example, if you have several departments and sub-departments, I don't know, teams in an organization, then most likely you will have them, all these teams, sub-departments, and departments as organizational units. So, and basically, account is like a container for all AWS resources, like virtual machines, 3 buckets, lambdas, networks, and so on and so on. So when a new resource is created, it's always created within the account. And organizations and organizational units may have multiple accounts, but account may only have a single parent. In GCP, we also have 4 levels: organization, folder, project, and resource. And all resources in GCP must have a project, and at least one project. Like you have to have at least one project in order to create new resources. But again, using of organization and folders is optional. So we can see the main difference between AWS here. For GCP, project is a must, while for AWS, you don't have any like projects, you have only accounts. So with AWS, all resources always will be created within account. But with GCP, they will be created within a project, which can then be included into folder or into organization. And only if there are no organization and no folders, then user account will own the project. And in this configuration, when there are no organizations, folders, and user accounts on the project, it could be a potential problem here when user leaves the organization. So when organization entity exists, then projects will be owned by organization and will follow organization's life cycle instead of user's life cycle. And that means that projects are not affected when users leave the organization. And in addition, organization enables having a central control of all projects and managing access at the organizational level. So folders in GCP are very much like organizational units in AWS. So folders can contain projects or other folders, or combination of both. Okay, so now when we know that all resources are created within the account in AWS or within a project for GCP, we can look at VPC peering. So VPC peering. VPC peering basically enables you to connect VPC networks. So workloads in one VPC can access workloads on the other VPC. And both GCP and AWS have 2 products with almost the same name and intended for similar purposes. So in AWS, VPC peering enables connection to VPCs within or between AWS accounts or regions. But as we know with GCP, all VPCs are global and connection between regions is not an issue. So for GCP, VPC peering enables connection of VPCs between different projects regardless of whether it's the same organization or between different organizations. And by the way, you can also have shared VPCs. And with GCP, you can share VPC between multiple projects and have centralized administration controls, while with AWS, multiple accounts can share the same VPC. And it makes perfect sense, as we just talked about resource hierarchy and how projects used to group resources on GCP, but in AWS, everything is tied to an account. And of course, you can't talk about networking without mentioning load balancing. Both GCP and AWS have everything you need to set up a load balancing for your application. But the way they use to define their products is different. With AWS, we have two products that are usually expected in traditional networking: an application load balancer and a network load balancer. So application load balancer works on layer 7, which is application layer, or just HTTPS for short, to put it very simply. And network load balancer works on layer 4 or transport layer, and it can route TCP, TLS, or UDP traffic. And both load balancers can work with internal or external traffic. With GCP, so documentation of GCP cloud load balancing led us to believe that, excuse me, that internal and external traffic will be balanced by different methods. And maybe they really are, somewhere deep inside. But in fact, in the GCP console, it all looks very similar to AWS. The difference is that you have 3 options here instead of 2. So you have HTTPS, TCP and SSL, and UDP. So if in AWS we have the same product working with TCP and UDP traffic, in GCP, for some reason, it's divided into 2 products. Configuration of GCP load balancers is actually easy because it hides some technical details, probably due to the more ephemeral nature of Google's underlying network. So, for example, when setting up targets for load balancing, you can just select the instance group or zonal network and point group. But with AWS, before selecting targets, you have to manually tick all zones and select one subnet per zone where your targets are located, which makes GCP load balancing more flexible and easy. So basically, that's it. It was really brief touch on networking part of GCP and AWS. And I hope now I shed some light on the fact that different clouds sometimes have real differences. And if you have experience working with a particular cloud, you should not assume that you will find everything to be the same in another cloud. Sometimes that's really only about naming and branding, yes, sometimes, but sometimes there are significant differences. And yeah.
Sorry, I didn't mean to butt in. I'm just listening, and I've got a lot of questions, and I really appreciate you showing the difference and the different providers and everything. And if you got a few minutes, I had a few questions. Sure. And I think we got a little bit of time here, and I'm going to throw this out here. I said, what provider do you think is a better infrastructure for government cloud solutions? Because I saw your diagrams and everything, and I was looking at it and everything, and I just wanted to, yeah, you're smiling. So what is your best opinion on that?
Oh, yeah. So, actually when comparing features and, products of different cloud providers, one of the questions I often get is which cloud is better, right? And this question is actually sounds like the same question. Which cloud is better?
I'm stereotype.
Yeah. And to be honest, I really don't like this question because only you know what's better for you, for your company, or for your project. So there are just 2 many factors to consider, and every situation is different, really.
Mm-hmm.
Yeah. So only you know what's better for you. So we can't say, hey, like cloud A is like always better for government cloud solutions, or always better for something else, because you have to consider like a lot of things, right? And only on like after the proper analysis you can make a decision and say, hey, like in this case for me, this cloud will be better than anything else. But
Yeah,
for different case, different company, like different government organization, it could be different.
Yeah, and I guess that's what's really important, because in the past project I was working on, right, the thing was to kind of get it ready sort of in a hybrid way for the cloud, right? But the thing that always comes up, Andrey, is the fact of cost, right? And what kind of data that you put up there. And then also the accessibility of it. And then if you get into like, I'm just going to say, let's say it's like aircraft data or something like that, right? What, and then there has to be a trust there. So yeah, you can probably, and I'm sure you worked on projects like that before, where you had to have all those factors involved. There is the speed of it, and is that okay? I know I'm asking a lot of stuff here because this is a great thing you talked about. But we always do this, right? We did it before. So what is it? What is the most important factor? If I had a government a flight data, for example, what is the most important things for me to consider?
Oh, that's a great question. Yeah, so you have to consider at least following option, like following things. So first of all, you have to understand if there are any requirements from the government side, such as for example, as far as I know, often government tends to go with a like single tenancy. That means that you can't like share the same physical server with other workloads, even if it's completely isolated for you, right? For the end user. Still, we have this requirement, and that means that at least you have to check like that your cloud provider have this option of like single tenancy, that you can just like pin specific machines to your account, and no one else will use them ever. And then of course you have to understand like some like basic stuff, like okay, so government, but where the like users will be located, where the servers will be located, like do you need like some sort of private connection, or is it okay to go with like more or less normal cloud, right? Basically something like that.
Yeah, and then so okay, one more question, because we got like one more minute. I had so many questions for you. I think this is what you mean. So if I'm with the government, okay, even not the government, if I'm with company A and company B and there's proprietary information between the two, there may be a restriction on what certain people can see, right? So does that play into it, where you have this virtual connection or something that restricts some people? And how do you plan that out?
If it's more, if your question is more about the performance, right? Or then if you can plan it, like design your network with the performance in mind, then for sure there will be no issues, right? Because you always can like set up like I don't know, like auto-scaling group that will handle as much traffic as possible, and process all the data. And from the networking standpoint, right? So actually, I think all major cloud providers have the network like fast enough, right? And the bandwidth is enough. And if we'll think about latency, and we'll design your solution with these ideas in mind, then yeah, definitely performance will not be an issue, right?
Yeah.
And actually, to be honest, often our maybe products that we create actually don't need that much of a network, right? So because not everything, like, of course, there are some solution that demands like really fast networking, like, I don't know, like high like performance, for example, like some products in fintech or something like that. But for majority of products, we're actually good to go with the just usual networking, and just basic rules of design of like any network will enable you with the performance good enough for your product.
Okay, I gotta let you go. We'll come back in Q&A. Just kind of wanted to get a little bit of, I don't know, a teaser in there for everybody.
Sure. Yeah, see you in Q&A session then.
Yeah, you too. Thank you, Andrey. It was an amazing presentation, and I'll see you in a few. Bye. Have a good one. All right, everybody. Is he ready for me? Hey, how's it going, man? How's it going with you out there? Oops, I did it again. Sorry.
Hey,
where are you? I'm doing good. Where are you located? Where are you right now? Because sun's in California.
No, for me it's around 8:00 p.m. in the night. So I'm from India.
Oh, really? How's the weather out there? How's the weather going for you?
It's been raining for last 8 to 10 days continuously.
What?
Yeah, and the weather, like, it's pretty good and pretty bad also. Like, from the other perspective, from the natural calamities part, it's bad. But yeah, as for the weather is concerned, it's really good.
Can you bring your rain here? Because in California, we don't get any. I mean, dude, every time I look outside, I'm walking out. Guess what I see? Blue sky. That's all I ever see. It's so
that's the same comment I got from manager. Like, my manager, she is from California itself. Like, when I told her, like, it's been raining for more than 10 days, she like, dude, please bring that rain to our town. Yeah.
Please do it. Anyway, so what do you got for us today? What are you going to talk about? Tell me what's going on.
Yeah. So I've got very basic topic today. That's what, like, I have been working on gRPC. Like, everyone, like most of the people who work in cloud would be aware of the gRPC. Yeah. That's a protocol, how you transfer your RPC calls and all. So I'm going to talk about very basic of gRPC. I'm not going to go in advanced things and all. I'm just going to talk about how gRPC uses HTTP2 protocol underlying and gives you a robust framework that we currently are using across the industry. So that's what, like, my presentation is all about. Very basics part. It does not cover any advanced topic. It's just very basics, which everyone should know about.
I appreciate that, man. I'm really super excited because I definitely want to learn more and everything. I'm going to go ahead and share your slides, and I'm going to see you later, man. Have a good one. Have fun.
Thanks a lot. So hello, everyone. I'm Abhilash Goyal. I'm being part of Uber, and I'm part of RPC team, like in the Uber. So I've been associated with gRPC for around like 3 years now. And so in this presentation, we're going to look about how gRPC leverages best of HTTP2 and how it uses it to provide, very high performance RPC framework that can run on any environment and is being used across industry, and it's becoming, industry standard for all the RPC framework. So we're going to talk about all those in the slides. So the agenda will be very simple. Like, we'll just talk about two things: what HTTP2 brings in table and how gRPC2 uses those HTTP2 benefits, and how it modules into a gRPC to gives you a new and dynamic framework to use across the RPC's part. So question is, why HTTP2? That's a very broad question, and the answer is very simple to it. Like, why HTTP2 was introduced? Basically, HTTP2 was introduced to eliminate all the negative points of HTTP 1.x. So HTTP2 is being used, as you can read in the slide itself. Like, it's being there for utilize your network to its most the capacity. And how it does, we're going to look in the in the new slides. But like, HTTP2 is there to to maximize your throughput across the to your network, and gives you and your when you're loading your website and all. So it decreases the amount of time you waste your time to load your to websites and all. So that's why HTTP2 is there. I don't want to read to text one by one. Like, in the consecutive slides, we're going to look at those in details. So, if I have to brief the previous slide, because there was a lot of text over there, if I have to brief those, points into three main bullet points. Like there are a couple of others, but top three points that I want to discuss are: first is binary framing and the compression. Compression here means for your header compression, like once your header get transferred from your client to server, I'm talking about those part. So binary framing. So if you're going to talk about an HTTP 1.x or HTTP 1 or any HTTP version previous to HTTP 2, your all your data was transferred between client and server via text format, normal text format. If you're going to use any tools like Wireshark, just to peek into those packets, you're going to see actual text format. You can see, okay, you're doing a get request, you're sending a request, you're sending those headers, these are the body. You can look at those. But with HTTP 2 brings in a new way of transferring those packets, transferring those data into a new format called in binary format. So it's just the way HTTP 2 encapsulates your data to transfer between server and client. And compression, header compression, we're going to talk about in the next slide also. Header compression is basically like it uses HPAC technology, HPAC, algorithm to compress your headers. So that's why it is more compressing your data when it is sending across the wire. And second part is multiplexing of HTTP2 calls over the single TCP connection. This is the single most important point of HTTP2, that is chaining all those performance improvement that HTTP2 is bringing on the table. So I'm going to talk a bit about this multiplexing thing. So if you talk about HTTP 1.x and HTTP 1.0, so like there was a limit to number of connection that your client can open. So you can understand this in a way. If you want to open your facebook.com in your Chrome, and there are multiple segments, right? So there are friend requests, there are your page information, there are some notification, there are some messages. So if you want to grab all those information from Facebook server, your Chrome or your client has to initiate multiple connections. So it has to do multiple connections because a connection can support only one request and one response at a single time. So in order to give you maximum throughput, and in order to actually work in parallel, it used to open multiple connection. And as you all know, connection has a cost, because connection is consuming some of your memory, some of your system memory. It is consuming network, and connection are not cheap. They are very expensive. So like there was a limit to number of connection. So that limit is around 6, as far as I remember, 6 connection per host name. So your Chrome is going to open 6 connection for a particular host name, and then is going to send those requests over there. So it's a very tedious task, and it's very expensive task. And it brings head of the line problem. What exactly head of the line problem is? So think of it like couple of requests has to wait until a next request has been completed. So first request has to send to server, then response has to come in, then only your request number 2 can goes in. So that brings in head of the line, a couple of requests, thousands of requests are waiting for a response to comes in. So that's when HTTP2 comes in, and it solves this problem called head of the line problem. And the second point that I want to talk about is your request prioritization. So request prioritization is like you can send multiple requests, and each request can have some priorities. So with that priority means like this request is going to be entertained much faster than your previous request on your other request. So this you can think of this in a way like in your any website, PayPal or something. You're doing some payment, and that payment notification or the payment has to be the highest priority message that to be sent over the wire. So that particular frame can be set with the highest priority, and network is going to respect that priority, and your request and response are going to be covered in that part. So all those things combined together gives you a performance which no other protocol was able to provide you in the past. That's why HTTP2 comes into picture and solve all those things for you. Going forward, what does binary framing layer does? So like as I've already told you, like there were like couple of things over there, like HTTP2 TP2, I told about 3 things. Now we are going to go over details over this. So binary framing layer, as we already discussed, like this is a new optimized encoding mechanism between the socket interface and the higher HTTP API which are being exposed to our applications. So and if you're going to look at this slide, right? So HTTP 1 used to send your data into a new line delimited plain text format. Basically, everything is your new line delimited, and those are like plain text. So if you're going to use Wireshark, you can actually peek into the those packets and see those data. Okay, this is the post data, this is the host, this is the content time, this is the content length, this is the content, this is the headers that I'm passing. All those information you can directly see on those Wireshark information. But in HTTP2, instead of sending those as a string, as a plain text, it send this in a something called binary format, which is new to HTTP2. And this HTTP format, it divides these two information into two parts: header frame and data frame. Header frame will contain all your things like post, host, content type, content length. Do it contain any headers? Does it contain any parity? Does it contain any other information that you want to, basically metadata information you want to send across from this request? And your content is basically your data frame. So you said, okay, message hello, so you want to say hello to Michael. So hello Michael is going to be sent as your data frame, and your headers is going to be part as a different frame. So we're going to talk about this in a while. So basically, to understand this part, we need to understand three type of thing. One is called stream, message, and frame. Like these are the terminologies that HTTP2 gave us, and these are like very simple part. So going through those one by one, what stream look like? So stream is another concept that HTTP2 gave us, and you can think of it as a single request and response communication. But in reality, what it is, like a request is going in, it has some number which says, okay, I belong to stream number one, and another request is going parallel. It says, okay, I am my stream identifies two, so I belong to stream number two. So basically, its stream is an independent bidirectional sequence of frames which is exchanged between client and server within HTTP2 connection. So this is the theoretical part that I use from actual RPC RFC for HTTP2. So now, like, every request which is going over the connection will have some ID to identify itself, which means like every logical request is given some stream ID unique to that session. And just to avoid confusion, and just to avoid any collision between, so every frame which is being emitted by client uses a odd number, and every request or every data frame or every header frame that is being sent from server has some even number. So then, like, you can see, okay, this frame was being sent by client, or was this frame sent by server. So basically, this is the way you can send multiple frames in a same connection. And one more thing very important over here, the order in which the frames are sent on a stream is a very significant, because the recipient is going to process all these frames one by one, and is going to deserialize them to form a complete message out of this frames. If I'm confusing you guys, like, just bear with me for a couple of next slides. So like I like we'll come to this slide after a couple of slides, because this tells you, okay, how your stream lifecycle will look like. So I'll come to this slide in a couple of minutes. So like I talked about, I just talked about frames. So as I told you, sequence of frame matter, because sequence of frames will form a message. So I told you, right? Like if I'm sending a message to Michael, I'm saying hello Michael, and I will have certain header to it, like where Michael is actually sitting right now. He's in California. There will be some certain IP addresses. There will be certain port number. There will be some encoding that he will be expecting. There will be some server that he will be having. So all those information will go into header frame, and my message saying say hello Michael will be going inside a data frame. So these both frame sequence together, they make a complete message. So message is nothing but a logical HTTP message. So this message forms a logical HTTP message. Like this is a valid HTTP message that was being sent by HTTP 1.1 or HTTP 1.0. So now the benefit is, like, instead of sending one frame, you're sending multiple frames, and those frames can be kept together to form a complete different message. And now we talked about streams, we talked about messages. Now frame is the smallest unit of communication. So I've been talking about frames a lot. So frame is the smallest unit of communication that can happen between any connection. So every information which is being communicated in HTTP2 connection is going to go via your frames. So how will your frame look like? Frame will have certain headers to identify, okay, like, do I belong to any stream, this that I've been talking about, stream identifier, this thing. Okay, which type of frame I am? Am I a header frame? Am I a data frame? Okay, and what is the length of payload that I'm carrying? So this length is going to define that part. So basically, just to go in a bit detail to it, this length define you the amount of payload that a particular your frame is carrying. So it can contain, from here you're going to see, 3 bytes is stored for this. So ideally it should be around 2 to the power 24 amount of like bytes that it can send. But ideally it is much less than this, because your client and server can your client and server might not be able to handle that much amount of payload. So maximum capped is 16 bytes, 16 MB, sorry. So, and if the clients or server wants to have maximum size, they can send a frame saying, okay, I can handle much more than this. Then your payload can be from a 16 byte to up till 1.6 GB or something. Like, I don't remember the exact number right now, but yeah, like this is how your frame are going to be transferred. uh, yes, I think and if I want to combine all of those into a single picture, you know I talked about connection, I talked about messages, I talked about frames. And how does it look like? We have a single HTTP2 connection which will have multiple streams. So multiple streams means like your multiple requests or responses are going in parallel, and each of these streams will have multiple messages, and each message can have multiple frames. So this is how your wire will look like. So this is how your actual, when your bytes are getting transferred from client and getting transferred to your server. So this is the actual snippet, okay, actual photograph that we have taken. This is how it will look like. And yeah, coming back to the this life cycle, this is a very important part that HTTP2 introduced. And I want to uh, spend some time to this particular slide, because this slide at first looks like, what does a stream life cycle would look like. So as I already discussed, right, that stream is an independent bidirectional sequence. That means a stream can be initialized either by client or by server. So we'll look at this from both perspective, from client of or from server perspective. And feel free to stop me anytime if you have any doubt in this slide, because this is a bit confusing and it takes a lot of time to understand this one. So if you see this stream is the single most important thing that HTTP2 introduced. And if I want to go over this, okay, like I'm currently sitting idle, like there's no stream right now. But if a server says there's something called push promise. So what exactly is push promise? So server can send me data without even client requesting for it. I'm going to repeat it again. Server can send me data, or client can send data to server without them requesting. So server can say, okay, client, wait, I'm going to send you some data. Even though you have not asked for it, but I'm going to send you some data which you might require in near future. Okay, so for example, you're loading a page. So server knows, okay, when you're loading this page, there would be a couple of images, there would be a couple of other information which client would be needing. He's not needing right now, but in a couple of seconds he will be needing it. So what server will say? Server will say, okay, I'm sending a push promise, that I'm promising you, I'm sending you something. And okay, the client will say, okay, I have received something called push promise. This is from the client perspective, okay, that he has received something from server called push promise. So he is reserving that streaming for it. The moment he receive a header, the moment he receive header from server, he's going to say, okay, I am on a half close state, because I am starting getting some data from server. Why this half close local? Half close local means I'm not going to send anything over here. I am close from local side. That's why it is half close local. I am close from local. I'm not going to send anything to it. Only I'm going to receive it from the remote side. That's why in this state, it can only receive information. It cannot send any information apart from resetting. Like if a client says, I don't want any more information, then a client can say, okay, dude, server, just stop right now. I don't want any more data. And he can send, okay, he can send reset stream, or he can send, okay, or he can receive from server that I am done sending the frame. You can close this stream right now. So this is a complete flow looks like when your server send a push promise. But when your clients want to send some information, for example, I am uploading an very high definition photo in my Facebook, and then images around 4 MB or 5 MB, and server won't be expecting that. So client says, okay, server, you don't know anything, that client is uploading that information, so I'm sending you push promise. So the stream is going to get reserved for local, and after it has sent some information, it will be say half close remote, which means I am close for remote. So remote cannot send me anything. I'm close for it. I'm only going to send data to server, and the moment I am done sending the data, I'm going to send, okay, this stream has ended, you can close this stream now, I'm done sending it. Or it is going to send, okay, there was some disconnection in this stream, I'm going to reset this stream. Or if the server says, dude, stop, you send me enough data, I'm not able to handle it, at that moment also your stream can get go to a closed state. So that means your client or your server can start a stream or can start a long-lived connection from either side. So we are going to we are going to connect a picture, why this is very important and how gRPC uses this technology. And other flow is like a normal flow. I'm sending a header. I'm can be I'm in open state. I'm open to receiving any data, and I'm open to sending a data, and either one of can close the stream. Like this is normal flow in which it is not getting reserved either for client or for server, but it is being used by both. So looking at this picture, you're going to get a rough idea about how your state of streams behaves. So now, if you're going to look at this picture, you'll have something different in your mind. This stream is not a very simple thing. It is being controlled by your client and server, and the way frames are getting in these streams are being managed, and the way all of this stuff. So yeah, now we have learned enough about the first part, binary framing part about the HTTP. We are going to look about the second part, which is request and response multiplexing, which I already told in the beginning of presentation that this is the utmost important property that HTTP2 brought to table for us. Think of this from perspective. If you were in HTTP 1.x, okay, 1.x, and like same example, and if you want to send if you want to reload a page, or if you want to load a Facebook, or if you want to load a YouTube, which is very content heavy. So to make those requests, your client has to make number of connection, and all those requests has to go to those connection in parallel, and there could be multiple connection open, and your server is going to crash, because there are number of connections getting open, and every connection consumes some memory, have some compute, all those stuff. But HTTP2 brings the ability to break down any message into independent frames and interleaves them on the stream, and then reassemble them on the other side. So I'm going to repeat. HTTP2 has the ability to send independent frames. So like these are the frames, and interleave them. It can just send it, and then your client or server is going to reassemble those frames to form a message, and then work on this. Is the single most important enhancement that HTTP2 has brought to table. In fact, it introduces a ripple effect to numerous other performance benefit. For example, it introduces multiple requests can go in parallel without blocking anyone. Multiple responses can be sent without blocking anyone. We can use a single connection to deliver multiple requests and response in parallel. You will be delivering a lower page load time by eliminating unnecessary latency and improving the utilization of available network capacity, and many more. So I'm going to go back a slide again. So ability of HTTP2 to send, sorry, slide back. Ability of HTTP2 to send your frames into multiple frames to form a message, and then ability of other side to assemble them into a some logical HTTP message is that's what we're talking about. And this single functionalities gave HTTP2 ability to multiplexing, and this just blew the internet, and in this way, like, you're able to load your any page, any web content very very frequently. So just to give you a demo about how efficient it is, like, this is not demo by me, like, I have just using that who has created the HTTP2 demo website. If you're going to look at this, right, so sorry, just bear with me. Yeah. So this particular image was formed by 200 images. So to load 200 images, your server, your Chrome is a client. It will be making multiple requests, and it will be getting multiple response, and then your client will be forming all the requests to form a bigger image. It is taking 5.45 seconds, just because I told you about head of the line blocking problem. And if I'm going to run the same thing over HTTP2, just look at the rate, 1.69. It is more than one by fourth of the performance improvement you're getting. And that too, over here I just use single connection. It was just because I can send multiple requests to get this 200 images, and those responses can be collected in parallel. It's giving me ability. If I'm going to just refresh this, right, so you can again see the data, like again it's taking around 5 or 6 seconds, and HTTP2 is going to take even less, because that image would have got cached in your local HTTP2, sorry, your browser. So this, you can see the power of HTTP2 that is bringing it with us. So now enough of the HTTP talk. Now we want to look into actual scenario. Why gRPC? How gRPC uses these tremendous HTTP2 capabilities. So if someone has used gRPC, they would be familiar about what channels are, what RPCs are, what messages are. So channels are basically created at the client side when you're creating your client stubs. So it is more kind of a connection to a server, and using this channel, you're going to send your RPCs, and each RPC is going to contain some messages. So think of it in form of a connection, like you're forming a connection with server, and you're going to use this connection. It's not a connection. I'm just talking in a virtual way. It is a connection, and this connection is going to be used by your client, which is who has initialized this channel, to send multiple RPCs, and each RPC can contain your response, your request, your headers, which will be passed on as messages. So combining together, you have a channel, you have multiple RPCs. In RPCs can have multiple messages. Okay, so moving forward, so just to go in a bit detail on this, what your channels are. So channel represent a virtual connection to an endpoint. So on a surface, connection channels provide an easy interface for user to send messages. To you, it will look like, okay, you just have a channel, you just do dot send. You have a server, you have a request body or something. You're just going to send to it, and but under the hood, there's an incredible amount of work that is going on to keep those connections alive, healthy, and utilized. To HTTP2 connection, because I already told, like channel is basically an HTTP2 connection. So channel is backed by your HTTP2 connection. Now it is the responsibility of gRPC. How does it leverage these HTTP2 connections? So gRPC uses a module called connection management, which is found by two things called name resolver and load balancer. I'll not go into much detail on it because that's out of scope. But just to give a brief overview about those two things, like we talked about, gRPC uses connection management to manage those HTTP2 connections under the hood. To the user, it will just be a single channel, and you are never concerned about what is going under the hood. Under the hood, gRPC is maintaining some kind of management to manage those connections. So it uses name resolver. So if you're using gRPC, you would have seen that if you want to connect to a server called server X, you just say, okay, dot send to server X, and then you pass in your request. So it is the name resolver, which is going to be resolve that name into IP addresses, and it's going to send that IP address to load balancer, and load balancer is going to make some connection, HTTP2 connection, okay, for that IP addresses, and it's going to keep those connection healthy, alive, and utilized, so that whenever you send a message, you won't be having any problem. You won't be getting any error saying connection lost, or connection reset, or connection or a reset, or not in the state of sending data. So that error you don't see much frequent, because incredible amount of engineering has been done under the hood. What RPCs are basically plain HTTP2 streams, which are sent over the HTTP2 connections. And what messages are nothing but your data frames, or your header frames. So now we are seeing, right, how gRPC and HTTP2 are connected. And moving forward, like this is a single most important functionality which gRPC brings to us, which every developer or every person who's work in gRPC loves, as this streams. So gRPC gives you four kind of streams: unary streams, client streaming, server streaming, and bidirectional streaming. And if you're going to think about this in a bit like if you're going to extend to it, like you're going to get some feeling that I just explained about how client streaming would look like, how server streaming would look like, how bidirectional streaming would look like. So you remember that part, right? I'm going to go back to some slides over here. This stream lifecycle. How does your client streaming look like that gRPC gives you? How server streaming look like? How your bidirectional stream look like? So if you want to initialize client streaming, that means client want to send a regular data to server without server asking it. So client will be sending push promise, okay? And if you want to start server side streaming, so server is going to send you push promise. So in that way, your gRPC tools, gRPC those ability are coming from this streaming life cycle. That's why I told you this picture is really important, and this is getting utilized to give you all these functionalities. You can just send if you know, okay, your requests are very heavy, you can start client streaming. If you know your responses are very heavy, you can do server streaming. And if you know both things are very heavy, so you can just do bidirectional streaming. So client will have a separate stream, server will have a separate stream. They both are going to send frames over those, and gRPC is going to use connection management somewhere to keep those alive, healthy, and utilized. So that's how we complete a picture. And just to look at this a pictorial way. Your channels are backed by your HTTP2 connections. Some says that like although it is only single connection over there, like but multiple connection can be configured based on your configuration, but ideally only single connection is there per channel, because you don't require many connection. And all those RPCs are sent over the single connection, and each RPCs, if you're going to send data, that data is sent in form of your frames. So basically that's how you complete your picture, how gRPC and HTTP2 are connected, and how gRPC is using HTTP2 functionalities to give you a framework which was missing from industry. And just to completing my presentation, what exactly is next in this one? Like, okay, gRPC over HTTP2, but the research is going on with the HTTP3 part. So why HTTP3? So HTTP, if you see, right, there is one issue with HTTP2. That is not an issue with HTTP2 ideally. That is an issue with your TCP. So HTTP2 uses TCP TCP under the hood. So if you have gone through your networking classes in college, so what exactly is the difference between TCP and UDP? TCP, if any packet is lost in the transition, so TCP congestion window reduces to half. So basically, like the amount of data that was being sent, now only half of data is being sent over that single connection. So that is bit of the problem with TCP, or problem with basically HTTP2. So just to solve this one, what is going on is to use something as of UDP kind of thing. So there is a new protocol called Quick Protocol. Quick Protocol is nothing but advanced version of UDP over like which uses the same kind of congestion control what UDP uses. And this Quick Protocol is being named as your HTTP3. And now there are some work going on, to gRPC over HTTP3, which ideally, might gain something, might not gain something, but the benchmarking has not yet been done, and it will be very interesting to see what are the benchmarking result. But to give you a note, as per the HTTP2 draft, the negative effects of HTTP2 is outweighed by the benefit of it. So I don't think so. That's my personal opinion. I don't think much benchmarking enhancement will be seen in gRPC over HTTP3. But who knows? Like that's an open question. So that's all from me. Any queries now? Like that's from my presentation. Any question now?
Wow. Dude, hold on, Abhilash. I've been writing down questions for you. But wait, let me see how much time we got. Okay, it looks like we've got like 5 minutes. So I can start dropping questions in. Dude, amazing. Because I've kind of worked on similar stuff like this. We have what's called SiteMinder. I can't give all the details quite work, but in the HTTP header, right? I'm using Java, right, to extract out, for example, the user information and everything. But what I'm hearing from you is the fact that is it similar to you like a file, like a really large file, and you kind of can chunk it? Is that kind of what I'm getting out of it? Yeah, explain that a little bit more.
Yeah. So, like, can you explain the question a bit more? Like, are you specifically talking about the headers, or you want to talk about data?
Yeah, the data, right? Because sometimes, like in regular HTTP, it's like a big bunch of stuff in the data. You know, it's bloated, and I noticed that in your demonstration, right? But then I noticed your second demonstration, how fast it was, and then you said like segment 1 or 2, whatever. Sorry for my ignorance here. But it's like you can chunk it, and then it'll put everything together when it gets over to the server or the client.
Correct. So this ability comes from, as I already discussed, right? That HTTP 2, has the ability, like, it can send your data into chunks.
Yeah.
Okay, and you can define the size of the data. So by default, size is around 16 MB. And it can go up to 1.6 GB also, but that depends upon your server and client if they're able to handle that part.
Right.
And given that functionality, that those data can be sent in parallel. Like, you don't have to send those data in a sequential way. That data can go in a parallel way. So if you want to load your 200 images, you don't have to wait for individual images to load. You can send in 200 requests, and you can get 200 responses at a parallel. And then you can just bind those requests and form a complete picture out of it. So that's what HTTP 2 gives you benefit, and this benefit comes from your multiplexing, the ability that HTTP 2 brings with it.
Yeah. No. Okay. And so another question. I was like, for example, let's just say there are APIs that support this, right? For like a commercial software. Are they already really starting to, move with this in this direction of HTTP 2? For example, like if I have like Jira and I have APIs and I want to talk to HTTP or something, are they already supporting that, or is it new, or what?
It is not like most of the browser are HTTP 2 supported as of now. So the numbers that I got last time, it was around 30% or 35% of the total traffic is going via HTTP 2. That's a huge number. And if you see, like if you see in this part, right, when you're talking about specific server you want to talk to, it depends upon the server implementation. Like if this server is exposing a gRPC endpoint, that means the communication is going to happen over HTTP 2. But if that's a REST endpoint and you're going to hit it via normal REST, so it will be HTTP. It will not be HTTP 2. So that part is your server part. If server is able to handle, if you can connect to server in HTTP 2, then you'll be seeing this information. That depends upon the server, not on the client. So server has to be HTTP 2 compliant on that part. So,
and then,
so that's why if you see, right? Yeah.
No, that's cool.
So
good.
See, right?
Yeah.
So if you see, right, so if you see various startups, right, so then just to see, like, even for a software that we are streaming right now, this StreamYard, it will be having thousands of microservices running across it. Okay, so inter microservices are always on HTTP 2, always on gRPC, because they need to be very fast. You cannot, inter microservice communication cannot be slow, because if those communication, you're going to see the ripple effect out of it, right? Like I'm talking right now, my audio is going all over the wire. It's going over the StreamYard server. It's getting processed. It's going to get transmit to all the clients right now.
Right.
Okay. If the backend is slow, then there would be a lot of discontinuation between what I'm saying and what you're saying. There will be some lag. There will be some jitter and all. But if the backend is fast, okay, then only we're going to experience this seamless performance over there, right? So like it depends upon your backend. So most of the inter microservice communication are HTTP 2. But your edge connections, like because edge connection are not company defined. StreamYard cannot say, okay, like if I'm opening this StreamYard in my Python code, StreamYard cannot ensure, okay, that will be HTTP 2 connection. That's why always the edge connections, might be HTTP 2 or they might be HTTP or simple REST endpoint. But the inter microservice communication across the company, they are always on gRPC or always on HTTP 2.
Yeah, and you can control that. And you control that, right? Because if I'm in a company and everything, I can control whatever that is gRPC or HTTP 2. Got it. Thanks for that, bro. I gotta go. We gotta go. We're gonna come back in Q&A. We're gonna be picking your brain more. This was so awesome, man. I was just sitting there going, whoa, this is so much information. You could just tell I got really excited. And I really love your enthusiasm, too. You were just, like, doing a really great job. And you explained it really well. I really appreciate it. So I'll let you go in a minute, and they're going to do some announcements. And then what I'm going to do is bring everybody back in. Okay, let me do that. So so we got announcements coming up here, what I understand. So take it away if they want.
For all those awesome people who take care of our iOS devices, we are organizing our iConf Summit for Swift developers. And this summit is no exception. During the next week, you can get it at 50% discount. To get the deal, just use our special promo code SUMMER50 at checkout.
All right. Before we start the Q&A, because we're going to get all fired up and talking that topic, I just want to say that person right there who was doing the announcement, that's on it. And let me tell everybody there, she needs a big applause. Seriously, everybody clap for her, because she has done a really good job. This whole enterprise, we're all nodding. I can see some nodding in there. She did an amazing job. Anna, we just want to tell you thank you. You did an amazing job on this entire summit, all the hard work, and we can all see it paying off. I mean, the speakers were phenomenal. And I just want to say again, this other summit, these other summits coming up, everybody, they're just such a fast track way to learn information, just like all these great speakers that I had here. And saying that, I'm gonna start bringing them in. Abhilash, what's up, man? And then I got Andrey, and then I got Ivan. Hey guys, what's up? How's it going? How's it going? Hey, so we're gonna have like a round table here and everything, and I've got questions for all of you. They're personal, but at the same time, they're gonna be questions that anybody drop in, say something, interrupt each other. It doesn't matter. This is our forum. This is our time to just, tell everybody out there our experiences, and I know we all want to do that. So let me start with some crazy questions here. For example, let's just go to the first one here. This is real generic and basic. Okay, we'll just drop this in. This will be like the icebreaker. How security will evolve in the next 5 years, taking into consideration ransomware increase in 2020-21? Somebody just go. Answer that.
Okay. Michael, for me, it's a very moment-to-time decision to make a lot of decisions because they are increasing very fast. The attacks are increasing. If you look last year, the ransomware increased a lot. We are noticing a lot of big companies being kidnapped by ransomware. Then we started, it's like what you speak today or talk today here. It's about what we are doing. You need to start to protect your company, and you start to have new ideas, because the hackers are ahead of us. They look at the last day updates. They try to get the companies which doesn't apply this change, these patches. Then I think the next 5 years, we start to try to get the hackers first, get the security first with the hackers. Because nowadays, okay, we do not put so much budget on the company, but next 5 years, sure, this budget will increase a lot for all big companies. Nowadays, like we said before, it's like the budget is small, but after an attack in a big company, the other companies start to look, wow, I need to improve my security. I need to put more money on the budgets for the security team.
But we're not doing it.
Put more money. We need this. We need good firewall, good solutions, more people. Sometimes they have only one guy to be the security guy. And this guy need to sleep, need to take vacation. He has weekends.
What's that?
Family.
Vacation. Sorry.
It works 24/7. It's what happened in a lot of companies. Have only one guy. We need to make these teams stronger, put more money, more solutions, and start to think ahead the hackers and think what we could do, like backups, disaster recovery solutions, close all the doors it could be opened. Then the first point is put more money in the next 5 years. After it, start to improve new technologies, maybe good firewalls. The companies who made the firewall and the solution need to be ahead too. They need to bring us new solutions, and it's like a cycle. We start to put more money in the market. The market start to try to get these new customers. and we start to create new solutions. Of course, we have a kind of good fight between the providers to bring us the best solution. Then we start to have this big good fight where everybody win. We win because we have a better solution. They win because they have more money, because we put more money in the market. I think the next 5 years will be this kind of fight.
Yeah, yeah. And I just want to add to that. Everybody out there that's listening, these are the experts in the world, and listen to what they're saying, because you got to put more investment, right? You got to put money and budget into security, because if not, everything just, it'll fall apart. Andrey, where do you see in 5 years this going, with what you talked about cloud solutions and everything?
Yeah, so I'm not sure if it will be like in the next 5 years or 10 years or 15, but definitely I can see the route where it's all going. And from my perspective, I think that we will see more maybe AI and ML in this area, right? I think it's already there actually. We will just we'll see like more and more like increase in this area, right? Because not everything is possible. You can't, as a human being, you can't just analyze that amount of traffic, for example, manually or something like that, or try to analyze like some potentially suspicious behavior. But if you have AI or like some ML systems in place, which can do this at scale, then it will do the job. And I think this is what we'll see, in next years. And also, in addition to this, I think that we will see like a shift of focus, maybe, because when we're talking about like security, like about some hackers attacking a company, they usually usually aim for two types of information. It's either some like company secrets, right, or it's user data. And okay, so company secrets will be there. We can just try to protect them more and more. But with user data, I think we'll see the like shift of the focus. So instead of like third-party companies holding our personal data somewhere in the databases, we will see, that we will be in charge of our own data. We will store it like ourselves somewhere, like maybe it will be like some mobile devices, maybe it will be, I'm not sure what exactly, but we, like every person, will be in charge of their own data, and only will allow sharing with the companies and parties that this person wants to share with.
That's awesome, because I agree with that, because I think everybody's we're seeing our world collapse, and it's becoming smaller and smaller. Everybody, like you guys talking to you, but at the same time, all of our data is being shared. We have no idea who's got our data, right? And so that's a really good point. If I could control it. I will say one thing though. This is mine, and then Ivan, you got it. So I was moderating for the cybersecurity one, and we had this extremely super smart guy from Georgia, the country, and he was telling me, well, we're going to get into quantum encryption. What? I mean, we're talking way crazy quantum, and then someone came in to talk about AI. So you were absolutely right on. I was blown away. So I need to ask you this, Ivan. No, I mean, I'm sorry. Sorry, guys. I'm like on fire here. Abhilash. So security, tell me about security, about HTTP2, because we're talking here in the next 5 years. Where do you see all this, and what is it?
Like if I want to talk about my part that I talked about in next 5 years, and so there has been a constant debate, about proxy and proxyless communication, like in this domain. So for example, if you talk about microservice communication, so take for example, there are 1,000 microservices running in a particular, for a particular startup, and think of the number of combination, 1,000 into 999. So like 1,000 into 999 is the total number of combination that this service can communicate with each other. And think of it a way ahead, like of a Uber scenario in which you are getting million requests per second, And so million requests per second multiplied by those numbers, you see those numbers, right? When you look at those numbers, there are like crazy numbers of requests and responses that your service need to handle. So there has been a constant debate about proxy and proxyless, how this communication is going to happen. Do you need some proxy in between when your communication is happening, or do you want this communication to happen without any proxy, called proxyless? So, like what I see in next 5 years is, I don't know, will proxy win or proxyless win? I don't know. But whatever will win, it will be a very generalized solution. Like you don't have to much wait on configuration part. It will just be a plug and play, and the security part will be like security, as he already told, will be like company has to invest more on the edge security. For example, your company internal network has to be protected by a world class firewalls, so that your intercommunication, like inside your company, you don't have to worry much about security, because security comes with a cost. It comes with some compute, it has a cost. So you have to pay that cost, you know behind the company, not within the company, so that inside company everything can run in a very simple way. So in next 5 years, what I see is the frameworks that we are running for service mesh kind of technology, like when you want to talk in a billion requests per second, or those will be very 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 sophisticated tools, and you don't have to worry much about the scale at which the requests are coming, and will your service be able to handle that much of traffic and all. So that's what I see.
That's awesome. In fact, that kind of goes in, and everybody just drop in on this next one here. What are the patterns to deploy secure websites? Because I mean, there's got to be some patterns out there, right? I mean, so just go. You guys just talk.
Start.
Yeah, start. Go ahead.
Perfect. There is no patterns, because each website has his things, his considerations, his specific points. But firstly, you need to have a protocol, safe protocol to communicate, like we saw in our presentations, especially the last one, where you could look the HTTP2, give more safety, and etc. You need to have the site protected, the server protected. If you could have this behind the proxy to be safer than open, even when you have no important information, maybe you could say, okay, my site's not so important, just have few data there, but if it's somebody enter on this server, could exploit your network, could move to another server, then you need to have everything behind the proxy, have a good firewall, have all the protocols, security protocols, and made a good hardening on your network and in your server. You need to fit it with what you need to deliver to your customers.
Right.
So maybe sometimes you need to have a file server. If you have a file server, you can close some ports. But if you have only a service, maybe a B2C site or something like it, you could close a lot of ports, put a proxy, and validate every connection. I think it's the basics to start.
Right. Yeah, and it sounds like as we are like these architects, we kind of have like a checklist, right? And then when they give us our requirements, then we can kind of check everything off and say that.
Exactly.
Yeah, and so I have a question also. Andrey, do you see that in your job there, what you're doing? Do you see is there a pattern, or is it just depend on the customer requirements and all that?
Yeah, actually, it depends on what you mean by website, right? Because each website is different, right? So it could be just a couple of pages, like about me, like or hello world pages, and in this case, security is not that maybe an issue as it could have complex system, right? And it also it could have just a website as a UI to this complex system, right? And also it depends how deployed, because if you use some cloud or SaaS solution and you just own the contents only, right? Then you can control only access to this content. But if you are responsible for everything up to hardware server, right? Then it's completely different case, right? So Yeah, it depends on many factors actually, but generally I would say, you just want to make sure that you follow best practices, that you go with always update your software libraries dependencies, that you use encryption in transit and encryption when data is stored, something like that. I understand it's very broad, but really it depends. Yeah.
Well, which is important, right? Because when you're presenting your solution, all that what you guys are saying is really vital. And those are the things I think that are really missed, because we're all thinking about clicking on the button and, whoa, look at it, it's really cool what it does, but it's also security. Abhilash, what about you? Have you implemented the HTTP2 for any, customers? Or you don't have to say, but you know what I mean? I mean, have you already implemented this and all that?
So I completely agree with the Andrew's point. This depend upon the use case. So as I already told,
Yes.
the HTTP2 things that I told you is I have implemented it for the inter microservices. Like for example, like how
Awesome.
you're like if you look at when you talk about deploy website ideally is nothing. Okay,
Right.
it is what your backend services are first deployed to some data centers, which Andrew would be knowing much better. Okay, because those
Right.
data centers need to be very secure. Like website is nothing. The website, if you see, is just a good representation which you are seeing, but in the backend it's an incredible amount of data which is getting processed just to show you that data. So all of the stuff is hidden behind firewalls, are stored in your data centers.
Mm-hmm.
Those are deployed first, and then a proxy or a what you call edge, what I can say, edge to my website is exposed to the world. So those APIs, for example, you have some public APIs, right, which anyone is free to hit. So those APIs are public, and because those are being hit by your website. If you're going to open streamyard.com, like I'm seeing you in this picture, like this is just a representation, but in the backend just see the amount of work is being done, that is being done by firewall, that is being done by Andrew. All of this work is being done. So when you say deploy a website, right, it is not a website, it is complete services, it's complete company that is
Yeah.
getting deployed in a data center.
Yes.
And then it depends on you, like what price you want to pay. Do you want to pay price at the uh, what do you call at the public APIs, like the proxies that we are exposing to the whole world, or the price you want to pay to internal to the company? So so the pattern that you told me, right, it depend upon, like, do you want to use hello world website, which there is no backend, there is just you click hello world and the HTTP2 does itself. Okay, hello Abhilash or hello Andrew or anything comes up, there's no backend to it. But when you talk about something bigger, then there's a completely different pattern, and depend upon the company you're working on, their budget. They want everything on AWS, they do want everything on Google Cloud, or do they want their own cloud solution, because they cannot trust Amazon, they cannot trust Google, because they might be their competitor. So they want their own cloud solution. So it depend upon the use case, it depend upon governments also. For example, there is some government which will not trust Google, there is some government which will not trust Amazon. So then you have to come up with different cloud solution. So it depends upon multiple factors.
Right. And
Mostly I
that's
think it's the yeah.
no, I'm sorry. That's a really good point, because I think that question was kind of rhetorical in a way. In other words, it was a question like everybody thinks website, right? But then you're thinking back in, and I know you guys are too. You're thinking the architecture. So I'm Mr. I'm not gonna say dumb, but I'm Mr. Not very not informed and not experienced, and I'm gonna give you requirements. I want a website, okay? But then you tell me, now wait, for example, I want to put you into the cloud, and then there's this whole back end like you talked about. How do you go about that with the management and try to propose this to them, saying you just can't, have your hello world website? So just step in. How do you go through that approach?
So I can go like in first on this one.
Oh yeah, everybody
So
jump in, but go ahead, you first.
so I think the first, when your budget is very low, so you're going to hire me.
Hmm.
I'm the backend engineer. When the budget is very low, right? Because you don't want any security, because Ivan will be costing you a lot because he's providing you security. And at this moment, you don't want security, because you just want things to get developed. And Andrew will come later into picture because you want scalability. Scalability means more customers are coming in. So at first you want some developers or some backend engineers like me, who can code for you. Okay, like this is how your data will get processed. This is how it will look like in your UI, and it's going to work fine for couple of hundred of users, and you love it. Now now Christmas is coming and users are growing, and your backend is not able to support that part. Okay, then you'll
Right.
go to Andrew. You'll go to Andrew. You'll say, dude, his backend services are working fine, but I want scalability. Then Andrew's going to talk to me. Okay, he's going to say, okay, how does your service look like? What all support is required for me? What all data center functionality you require? Do you require GCP? Do you require multiple instances? What is the billing? He's going to talk to you. Are you okay with Amazon billing, or are you okay with Google billing, or are you ready to set up your own data center for cost cutting? Then we both are going to get synced together and things are going to work fine. But on the Christmas Eve, there's some fine hacker who has hacked your system and costed you billions of amount. Then you're going to reach out to Ivan. Okay, he's going to say, dude, you seriously need some firewall to protect your system. And that way, gradually your system is going to grow. Then you're going to hire more backend engineers to write more services, just to bring down inter-microservice communication to more efficient, so that cost from Andrew is going down, because Andrew is going to cost you a lot. He's going to cost you per CPU clock. He's going to cost you, per compute that you're using. He's not going to leave you. So you're going to hire more engineers like me. Okay, dude, we need to cut the cost from Andrew because we want less CPU, less compute agnostic thing needs to be done. So all of
Right.
these things will grow gradually within a year, 2 year, 3 years. The system is going to get stable. Others can add, to my Andrew, and Avon can jump in.
That's an
Yeah,
awesome.
actually, Abhilash, yeah, you put it like really nice all together.
It was awesome. I know.
Yes, exactly. I agree
Anybody
100%
want to add
with
to that? Yeah, go. Just go. Anybody want to add to that? Because that. You want to say anything, or we're all good?
I agree 100% with Abhilash. It's like he said, you start small, the people like a lot. Okay, let's go ahead, and you start to have a lot of points. You need to improve a lot of things. The back, they put more power to process everything. Okay, this is what you have nowadays, and I agree 100%. This is the problem. Start small. Okay, everybody, wow, go ahead. When you put yes,
Everything's
1,000 users start to use it. Okay, it's perfect. No, nothing's working. It's bad, and that doesn't like. But you need to have this planning, this planification, have all the requirements, what you need, what's the target. Okay, we could start with 100 users. Okay, it's perfect. But if our target is, I don't know, 10,000 users at the future, near future, maybe in a few months, we need to start to think since the beginning. Because a security configuration could work fine for 100 users. We could have some kind of validation. It's not so fast, but if you put 10,000 users working, you could have some kind of problem. Processing, like Abhilash said, the protocol could interfere in this case.
That's
you could need to plan a different project since the beginning. Even when you made a POC, you need to think, what is my targets?
Yeah.
Where I want to go? How many users I will have in the future? Even
Right.
when you do a POC, you need to think about it, because the
Right.
POC could be very cheap, but after that, everybody, okay, it's perfect, it's fine for us. The cost could convert this project in not an option, because converts in a very expensive project in the future, and you could kill a good product.
Right. And then so this kind of leads in, this is for you, Ivan, but everybody's probably going to nod their head. Now we've got our wonderful system. Now it's running. And I just wanted to throw that out there to you. In other words, is it better? Yeah, he's laughing. I knew I'd get you.
Depends.
Similar problem what we were. And so it's a kind of rhetorical again, but explain it. Is it better to delete? And then you just talk thousands of users, right? I mean, now we're talking support. Guys, just go. Because I know this is a huge problem. Because I know for a fact I'm just going to say, for example, we work with Jira and Confluence, right? And we're ready, and the user leaves. But wait, I can't delete them because there's stuff that's attached to them. Yes. So go ahead.
It's depending on the system. Some systems you could maintain a historic information even when you do not have the user. You could disable a user. It's okay. But depending on the rotation of the user, imagine if you have a big company where you have at this moment around 20,000 users, for example. and you have maybe 10% change by year. In 10 years, you have a lot of users. Even being disabled, you have 30,000 users at the end of the 10 years, only a projection. Now imagine you maintaining all the users and segregating what user is disabled, what user is not disabled. It's a little bit complicated to maintain this. If you could delete a user, it would be better, but only if your system maintain all the historic. But if you need, for example, to consider some kind of historic data, and if the user doesn't exist, you have a problem. You need to maintain the user by historical information.
Yes.
In some cases, by RGPD law, in some countries, you need to maintain the user because you need to have could make a tracking to the past to identify something like, I create a customer data in our system and I leave the company. Maybe in 2 years more, somebody need to understand who created this customer. In this case, I need to maintain some kind of information. SAP, you have the information, but other system, maybe I need to have the user created in the system to link the information. Like, okay, this data was created by Costa. Who is Costa? Okay, but if you have the information about Costa, is Ivan Costa, it's okay. I could identify, I could track the information until my name and on the HR system and identify who is Ivan. Ivan is a guy from Brazil who is working here between this year and this year, and we could track this guy. If you could track, it's okay, you could delete. But if you can't track the user, can't track the information, you need to maintain the user.
That's all.
You need to think about it because in Europe we have LGPD, some countries in South America and in US have similar laws. Then we need to think about this kind of information. If you think only about the organization, it's better to delete because you have less users to maintain, to look, even when you create a filters to only see active users. In some moment, you need to look for license. Then you need to check if all the users are disabled, and you need to make a cross information to identify if all of the active users should be active or we have made some mistake, because it's easy to enable a user, then create a new user. Then when you disable a user, some guy from help desk could make a mistake. For example, if I leave the company and simply disable my user, but it's disabled in a way where the help desk could enable again the same user because they have all information. I could call the company, look, I have a problem, I can't log in. What's your name? Ivan Costa. Your number? Okay, top number. Okay, it's active again. Okay, I could enter in the company. It could be a risk to the company. You need to think about it, all these points, and in our case, we delete all the users by security, and we have the historic. We could track this user. If I identify, I look on the HR data, and okay, Ivan is the person, Ivan Costa, live here, have the phone, the cell phone, the mail, and etc.
Awesome. Andrey, what's in your experience on that question? Who is the best provider that handle? Are they both really good at handling users, or are you just shaking your head?
Yeah, so it's usually, it depends on you. Like they provide you like a platform, and you can build whatever you want to, with this platform. So it's up to you how you will handle using, right? So of course, like both AWS and GCP, they have like managed products for handling users, but I don't think they have some limitation that we should care about, right? So generally, like storage space nowadays is like really cheap. So you don't have to, delete users in order to save some space. No, probably it's not an issue anymore. So yeah, probably, just instead of deletion, just marking the user as deleted is maybe the better option, because it will enable you some tracking, right? But yeah, I agree. Sometimes like we could have something like GDPR requests for deletion of all the data. So yeah, that's another question. That's like completely different case.
No, that's awesome. You want to add to that there, Abhilash?
Yeah, I want to add one thing. Like it depends upon how do you define a user. Is it a customer or he is a company employee? If it's a customer, then you cannot save his data. That's by law. You need to delete the data, no matter how that data is linked or not. But if it's an internal to you, like you are if the user is an employee, then it's up to you, right? You can keep the data or you can keep how much data of that person. But if it's a customer, uh, if I want to delete my profile, I have to delete my profile. You cannot keep even a single copy of my personal information. So that's what, like, it depends upon how you define your user. It's a customer, then delete. If it's an internal user, then you can disable, or what we call a soft delete, that you're not deleting it but you are just marking it as disabled. So if in future the user again joins the organization, you just mark, okay, the user active again. So
That's
that's what I
awesome.
would say.
That's awesome, guys. We flew. We flew. There was so many more questions. I just want to say, everybody out there, guys, if you can post your contact information. I know it was on your slides, your LinkedIn, and I'm sure. I'm just saying on your behalf that you don't mind people if they contact you and ask you questions, right? We're nodding heads. Okay, good. Just kidding. Oh man, I gotta let you go. I really had a great time. Thank you for all your time. I know you spent a lot of time preparing, and it was just so amazing seeing you here. Any last words? Okay, let's go. Any last words? Anybody want to throw something out there and tell the entire planet anything you want? Just go. Just go around.
Thank you to you, Michael. Thanks to Anna. Anna contacted me.
Yes.
And made everything happens.
Amazing.
To you, it's my first time here. I'm very, 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 very happy to be here with all these guys, all this group. And thanks to you, thanks to Anna. And everything you want to know more, there's my contacts on the presentation. And feel free to look me in Twitter, LinkedIn, or by mail, and then open to answer any questions I could help everybody.
Awesome. Anybody else? Go.
Yeah. So also, like, thanks everyone. So thanks Anna. Thank you, Michael. Thanks, everyone who joined us, who spent our time, who spent their time with us.
Mm-hmm.
Yeah, cool. It was awesome. And yeah, also, yeah, feel free to contact me. And yeah, bye.
Abhilash, you're it. You want to say something?
So first of all, I like to thank Anna. Like I'm a very lazy guy, so she has to follow up with me like a couple of times. Like, presentation ready, I'm like busy with my meeting, so I won't reply. So like she's like so nice girl. Like she's been following up. Okay, presentation ready or not? She's bearing up with me. Like hats off to her. And you have been a very great like in this presentation. So thanks to you, and thanks to all the viewers and your like colleagues, that Ivan and Andrew, for such a great. And thanks to my girlfriend. Like she helped me,
you gotta get the girlfriend in.
She helped me fix the grammatical mistake in my presentation. So I'm very bad at all this stuff. I can just manage the technical stuff, but all the stuff, like, she helped me. Okay, like, you have to speak slow and all. Yeah. So thanks everyone who has been with this.
You did amazing, guys. I gotta let you go. Thank you so much. It was wonderful, and I hope to see you again in the next summit and everything. You were amazing. So wave, bye everybody. Bye, and bye. Okay. I guess that is it. Ditto, and triple ditto. I just want to say thank you to, you can see it. It's right. Is it right? It's weird, isn't it? Anyway, I can't even do it. It's that thing right there. It says Geekle. Thank you to Geekle for doing this. They are super amazing. I really like how, I don't even know how to describe it. I mean, you just bring us all together as one family. I'm listening to all these guys here and the guys and gals and everybody in this whole summit and all the summits. It's so beautiful. It really is. All of us is coming together and just having a time of just like sharing, and we want to share. And that's what's going to make us all successful. And I guess that's all I'm going to say. And again, I ditto. Thank you, Anna. You did an amazing job. And just keep it up. You're doing such incredible work. And all of those coordinators out there for all the summits that I've been in. You've all been super amazing and super nice to me. And you've really helped me out in a lot of areas. I guess that's it. And I just want to say thank you. And we will talk to you on the next summit. Oh, there she is.
Hi. Hi, Mike. So I would like to give you many, many thanks for joining us. I don't remember even what time you're joining us. I believe you are our Geekle ambassador, and I'm really, really happy to have you here, to have you with us. And also thank you to all our speakers. I can see that Ivan is still here, so thank you. Yes, and definitely this is our last block for the career track. I would like to give you, our attendees, many, many thanks for joining us, for being with us, for staying with us for this second day. And I hope that our next summits will be even more amazing for you. We would like to inspire, we would like to surprise, and I hope that we will manage to do that. So thank you for all your questions. Thank you for your support. Thank you for your feedback. This is really precious and this is really valuable. And I believe that due to your feedback, due to your help, we will be better. Thank you for making us better.
Thanks, Anna. Appreciate it. So I guess we go now, right?
Yeah, so we are ready to go. We are ready to finish. And I wish you all great evening, day, or morning. If you have any ideas on how we can actually become better, let me know. I will be really grateful, and I'm always ready to contribute into our development and improvement.
Thanks, Anna. Thank you again. I appreciate it, and I'll see you later. Bye, everybody.
Bye-bye.
Bye.